What's up guys, this is Kazi from cleverprogrammer.com. You are here to watch the Python tutorial for beginners. This is the ultimate tutorial. What I've done is I've taken every single video, put it together so you have everything in one place to watch. We're gonna cover all the way from how do you actually install and download Python in under 2 minutes to what are variables and strings and conditionals and while loops and for loops, things like that, all the way to building lots of projects. So we're gonna be building games together and we're gonna be building projects together, okay? So for example, you're gonna learn how to build a circle made out of squares. So we're gonna be doing lots of visual development as well. You are gonna be doing lots of exercises that are gonna be given to you with test cases built in, and you also gonna have access to projects in here, okay? And we're gonna be building rock, paper, scissors as one of our projects in this as well. I'm gonna shut up. I hope you enjoy this. Please do me a favor. We want to make sure that this goes out to a lot of people. So the one very small thing you can do that will really help us is if you just hit the like button and subscribe to the channel if you want to watch more of this type of content. Outside of that, another thing I wanted to tell you was if you want it all in one place, I do have it on my website. The link should be below, cleverprogrammer.com/learn Python. And you can make your account there, and that way you have all of this all in one place so you can have access to it. You can come back to it to view it and watch it. With that out of the way, I'm gonna shut up and move out. Enjoy the video, enjoy the Python tutorial for beginners. I'm excited for you in your journey. This is Kazi, I'm out. Today, we're gonna learn how to install Python in less than 5 minutes. So let's get started. Okay, so the first thing you have to do is open a new tab in Chrome or Internet Explorer or Mozilla Firefox. Go to your web browser, type in Python 3 download, simple as that. Click the first thing that your eye can see or can't see. That's how fast you should be clicking. And instead of Python 2.7, let's go to the latest version and install Python 3.51. You get this download bar at the bottom here. Click continue, 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 agree, right? You can read those licenses, but just do it. And simply hit install. So I'm gonna hit install, I'm gonna type in my password. Let's wait for the install. All right, so our download was successful. Move to trash. All right. After you're done installing it, I want you to do something simple and look for an app called Idle. You should now have it. And effectively here, you should be able to run your Python code. Let's try 5 + 5. Boom! It's giving us something. 10 times 20? Yes. X is equal to 5. X times 5? 25. It's working. Print. Hello. It's all working. Amazing. We're up and running, you guys, in just, I don't know, less than 5 minutes. Let us simply type in our terminal. If you're sitting on Mac, you would need to type in term like this, hit enter, and you should come to this screen. And if you type in Python, it should now be running your Python as well. And you should be able to just type your code in here. So this is how you install Python, and I will see you in the next video. Okay guys, back to where we left off. So we just did some simple stuff in Python, right? We can print stuff by doing this, and then it prints it out to the screen. That's cool. Now, what we want to do is we want to take it to a little bit of a next level. I want you to come up here and select new file, okay? This brings up this file here. Let's go back to our other screen and let us simply put this to the right side. Let's put this to the left side. And what I want to do is I want to write a few things here like print hello, print monkeys eat bananas all the time. And then I want to say, and notice how I'm putting these quotes. We will learn a little bit more about that later. And then I can say print 5 times 25, okay? And I am gonna run this. So I'm gonna save this first. You can save it anywhere you would like. Let's, for our purposes, let's save it in our desktop, or let's do one better and let's go here and let's call this practice exercises, and we will save it in here, printing, and I'm gonna go to run and hit Python shell, and you're gonna see what happens. So I'm gonna say run and actually run module. Okay, so I'm gonna say run module. That just means run this whole thing that we just wrote. So let's run it. Let's check out what happens. Boom! On the left hand side, it ran our entire file. Okay, on the left hand side, everything you type in gives you the result right away. So you can write 4 times 8, 20 times 6. But on the right hand side, notice when I press enter, nothing happens. So you're kind of like writing a story here. That's how I like to think of it. You're writing kind of a novel. And this is almost you having a conversation with Python. You're like, hey Python, what's up? Or in Python's language, 8 times 8. And Python is like 64. Here, Python is not listening to you. You write out your entire whatever you want to write, and then you send it over to Python, and then Python responds to all of that. Almost like you're sending an email to Python, and Python is sitting there, and once it sees your email, it'll like type stuff back to you. Okay, let's run it again just to check what happens, and I will run, and you can see that it runs all of that at the same time. So what I want to do is I want to give you guys a little problem, and the problem is how would you print hello world, okay? And I want to be able to test this for you guys. So what I have done is I've set up something kind of cool. I want you to go on, open a new tab. I want you to go to cleverprogrammer.com. And once you're here, I want you to click on Learn Python for Beginners. Notice that it's free. So simply go to that. And here I've put together a little exercise for you guys, okay? So once you start this course, you feel free to watch all of this on YouTube. It's available for free. If you want, you can also go to my website, and here it'll give you a little progress bar and everything, and you can comment and I can respond to you as well. And here, this is where I'll also put all of the exercises. So if you guys want to follow along this course and do the exercises, this is where you can come and find them. So let's click exercise 1 and start. Now notice you have a quiz here. It says, how do you print out hello world? So I'm not going to answer that for you here, although I'm sure you can figure out. And we want it to look exactly like this in Python 3. Just a little bit about Python 3 versus Python 2 is if you do this in Python 3, you're going to get an error. So let's just try it out on the left-hand side. Let's say print 10. You can see that we get an error. And if I do print 10, I don't get an error. So in Python 3, this is the correct way of doing it. In Python 2, you can do it just like this and it actually will not give you an error, okay? Just for something for you to know. So here, I want you to select the correct answer. And another thing I made for you guys is if you click this link, what I've put together is so simple. You'll have to like sign up. It'll be really short. And once you're done doing that, just click on exercise 1. And on the right hand side, you see that I want you to print out hello world. All right, so now that you're here, let's type in something like print 25 times 63 and let's run it. It gives me 1575. Great, let's hit submit. Let's see what happens. Oh, whoops, it says output mismatch and you failed to answer it correctly, okay? So you can click what's wrong and it'll kind of tell you what the answer is, or you can hit submit anyway and then it might also tell you what the answer is, okay? But I want you to try to figure it out, and I'm sure you probably already have. So I'm not going to tell you what the answer is, but once you write the correct answer, it'll give you a little green thumbs up and say, hey, good job, you got it, okay? So now I want you to try it and I'll see you in the next video. Okay, in this video, I want to talk about the turtle. So what is the turtle, you might be asking? Well, we're going to find out. Before we get into some of the more boring or the technical stuff, which is actually really fun, but before we get into that, I want you to be able to visualize the code. I want you to be able to see that what we type and what we do you can do something fun with it right away. Okay, and this is not just something for maybe kids. This is something that's going to be very valuable. I don't care how old you are, even if you're 200 years old, because visualization is a key tool. So if I show you that now, I think it's going to benefit you in the long run. And also sometimes when you're confused about things, you can try this thing out that I'm about to show you right now to maybe make those examples and concepts more concrete that you might be a little hazy about. Without further ado, let's get started. So what we are going to do is start doing something with the turtle. So I want you to do import turtle as your first line. Okay, import this secret command here. What it means is that some programmers who stayed up really late at night and wrote code and ate ramen noodle and that's all they did, they spent hundreds and thousands of hours writing all this code for you, and you just get to steal it by typing in import. So basically think of it like you have amazing powers at the tip of your fingers by using this command import, and you get all those powers. Okay, let's do my turtle is equal to turtle.turtle. Okay, and what we're gonna do is we're gonna say my turtle dot I don't know, let's do something simple like forward 100. All right, so let's see what just happened. All right, what is going on there, right? Let's close that. Let's start it again. So I'm gonna write this line again, and we're gonna kind of do like a slow motion, okay? We're just gonna play it out again. So I said my turtle, right after this first line that I did, right? My turtle showed up here, okay? Just to make it even clearer for you guys, I'm gonna start this thing again, and I'm just gonna write the first line that I wrote. So you can see my turtle showed up, okay? Now let's say I'm gonna do my turtle dot move, I keep saying move. Let's do forward and let's do 100, yeah? Let's try it, let's see what happens. Did you just see that thing go to the right? So that thing went to the right. Now, what if I wanted to move it up? Well, what you need to do is essentially it's like okay, it's like this. I want you to look at my face right now. So if I'm the turtle and I'm going in this direction here, I will go like this much, and then in order for me to turn left, what I need to do is first turn 90 degrees left like this, and then to move forward I just go forward, right? Like that. Okay, so we're gonna do that with our turtle. So let's do my turtle dot left, how many degrees? 90 degrees. Okay, now if you notice the turtle, now it's facing towards the left and it's looking at going up. So we simply do my turtle dot forward 100 again, and you can see my turtle is right over here. Now let's do some more fun stuff. Let's say my turtle dot right 50, and let's say my turtle dot forward again 100, and you can see we're starting to make interesting shapes now, right? Like, what is that? Maybe it could be a shirt, it's a ladder, I don't know what that is. But here's what I want you to do. I want you to create a square with the turtle, okay? And I want you to copy whatever code that you wrote, and I want you to paste it in the comments. So either if you're watching this on YouTube or if you're watching this on my website on Clever Programmer, I want you to go to exercise 2, the turtle, on cleverprogrammer.com, and I want you to literally copy whatever code you have and paste it here, okay? I read every single one of your comments, and I'll go through it and I'll comment on it. And other people will get to see what you're up to as well, okay? Also, on my website, I've linked you guys to a blog that says, read this on how to do more fun things with the turtle, okay? So if you go to this blog, it'll teach you what more fun things you can do, okay? So it teaches you how to create stars and some really fun shapes, okay? So that is it for this video. I will see you in the next video. Okay, in this video, I'm going to go over the solution to the previous problem that I posed to you, and also we're going to learn how to write the turtle, the entire thing, in one go. So, the problem that I posed to you is make a square with a turtle. Well, in your case, let's see how you could do exactly that. So let me find the file where we opened up the turtle. Let me close that guy right there, copy this line, and paste it right there. Okay, my turtle has begun. Well, the idea is simple. I take this line forward and go 100. Now, since sometimes programmers are lazy, I don't want to keep writing this over and over again. So one thing I can do to make my life easier is go to the line that I want to click on and I want to use, basically. Go to that line, click my mouse there, hit enter. It brings that down at the bottom, as you can see right here. And now I can just hit enter. So you can see my turtle just moved left, okay? Now it's facing up. Now what I want to do is move it forward again, and you can see that it's facing up again, or I'm sorry, it moved up. Now I need to make it face left. So how do I do that? I go to left, make it turn 90 degrees, and you can see it turn 90 degrees. Now I want it to move 100 again. You can see it move forward and 90 degrees and then 100 once again, and I have made the square. Now what I want you to be able to do is make a Python file, which means that, remember this thing that we opened up right here, where we write all of the code at once. So for example, I'm going to close it. I'm going to show you how to open it again. Okay, so I'm going to close this one and I will simply open it again, new file, or Command N. And I will go and put it to the right side just so I have these side by side. And I will say something like import turtle. Remember that command. If you don't use that command and you try to do turtle, your program will be like, what the heck is turtle? So by doing import turtle, now it knows what turtle is. It's like when you're talking about your friends. If you talk about your friend John, right? Like, let's say you're talking about your friend John to your mom or to your dad, and you're like, Dad, this guy, blah, blah, blah. Your dad's going to be like, who the heck is John? So you're going to be like, oh, yeah, you remember John from my 5th grade class? And then your dad, if you're talking to him, he's going to say, oh, okay, I know who you're talking about. So import is basically like, hey, Python, import that turtle that those coders wrote, and now we can use it. And Python is like, oh, that turtle. But if you don't have this import command here, Python is gonna be like, what the heck, what turtle are you talking about? You must be out of your mind. Anyways, we're gonna import this turtle. All right, so now here's what I want you to do. I want you to write a script that makes the turtle in one single go, okay? And I want you to make that square with the turtle straight up in one go. For example, let's come over here to our script that I've written. And if I write stuff here, it does things immediately, right, as you saw. But if I come to my right side over here, oh, by the way, just one quick note, whatever you do, do not name this file turtle.py. You can name it turtle_game or something else. Just don't name it turtle, because then it confuses this turtle here with this file and everything goes all over the place. So don't do that, because I ended up doing that and it caused lots of problems. All right, so let me just show you what happens when I run this file. I'll go to run, I'll hit run module and hit OK. And you can see that my turtle went and did all those things in one go. How cool is that? So you don't have to sit there, type it all in. You can just write it in one go and it'll do that every single time. So I want you to work on that square. But before you go and do that, I just want to show you what this file actually looks like. So if I go to, let's say, documents and Clever Programmer, practice exercises, and we take a look at this file, turtle game, it's just a text file with this code in here. Okay, that's really it. That's all that's going on in here. So I'm gonna leave it here. The code that you write for the square, I want you to either go to the YouTube channel and post it in the comments, or I want you to paste your code right here in the comments on cleverprogrammer.com, okay? I'm going to take a look at it. I will see you in the next video. Now, in the last video, we talked about how can you make a script that creates a square in one go, right? So I gave you an example of a script that does not make a square in one go. So I'm going to start off in this video talking about how to do that. So I'm going to solve that problem. If you haven't done it, go still try to do that problem. But I'm going to go over the solution, and then after that, we're going to talk about what the heck are variables. So let's keep going. So here, if I run this code, right, notice what actually happens. We get this thing, but we don't want it to go to the right and down. We want it to keep going till it makes a square. So I'm simply going to copy this code and paste it again, except for this line, I want turn 90 degrees, and then I want to turn 90 degrees and go straight one more time. So let's run this bad boy and check it out. Let's see what happens. Okay. And boom, we have gotten a square. So if this was your code and you copied this and you went over to cleverprogrammer.com, or you went to YouTube, my YouTube channel, and pasted it below, that would be exactly what you would need to do. Okay, so simple, go to Python for beginners and simply go turtle in one go, and you can paste the code right here. Okay, back to what we were talking about. Whoops, the video actually started. So let's talk a little bit about variables. Variables are very simple. It just allows you to store information somewhere. Instead of having to say, oh yeah, my friend with the white skin, or he has this length hair and his nails are this long and he's this tall. Instead of saying all of that, we store all that information in his name. So we just say John or Bob or whoever, right? That's exactly how variables are. Instead of saying all these things at once or having to remember them, you just store it in a variable, and then you just, recall that variable, and that's it. So something really simple, I can say Bob, right, is 5 years old. He is 68 inches tall and wears brown suits. Okay, now if I say Bob, you can see Bob. Or if I say X is equal to some big number, good luck trying to remember that number, but it's pretty easy to remember X, right? So you can say X, and you can say X plus 10, or you can say X minus X, and you should get back 0. Anyways, that's variables are very simple. On the left-hand side, you put what you want to store information into, and on the right-hand side, you put what you want to store in there. Okay? That's it about variables. I'll see you guys in the next video where we talk about strings. Alright, in the last video we talked about variables. You can see some basic examples. I stored all this information in the variable Bob, and then as soon as I typed in Bob, I got back all of Bob's information. Just a quick thing I want to say before I continue. If any of you are having problems downloading and installing this Python stuff that I've shown you, if you're on Windows or Mac or any other system, I want to show you I want to really quickly show you a website where you can get all of this information, or you can pretty much do everything we've been doing right on here. The website is called Trinket.io, okay? And here's how it works. So on the right hand side, you can see that if I run all of this code, it draws all of that stuff, okay? And they have a bunch of great examples for you guys to try out. So you can go to Python and you can discover a bunch of great examples that you can do, okay? So for example, you can look at this example here and maybe get an idea of how to make some really cool shapes using the turtle module in Python. Okay, so let's stop their code and let's start ours. So if I do import turtle here and I do my turtle, or you can call it really whatever you want. You can call it my John if you want, is equal to turtle. And if I say my John dot forward 100 and I run this, invalid, object has no, okay, I misspelled turtle here, run it, and you can see that it draws a turtle going forward. Now let me bring back their code and let's do it. So for example, where it says black here, let's write blue. Okay, pen color, background color, that is. So you see we changed the background color. So that's a good way to see what this stuff is doing. You can change this color to orange maybe and see what that does. Okay, so the first turtle that gets drawn is actually being drawn by an orange color. Okay, so great place to come and try out stuff. Okay, Shrinkit.io. Now, going back to learning about strings. So let's go over here, and strings is literally the exact thing that you type. Okay, so let's say I wanted to say hello world. If I did print hello world, I would get back an error, and the error would say invalid syntax. I don't know what you mean. So let's try to type it in the Python 3 way, where you have to put a parentheses after print, because print is something called a function, which we will cover later. So let's try hello like this and hit enter, and you can see the error I get. It says name hello is not defined. So it has no idea what you're talking about when you write hello here. It's looking for the variable hello. We have the variable Bob here, we have the variable X, but we never defined variable hello. But you're like, no, that's not what I'm trying to tell it. I'm trying to tell it to exactly like say hello, not some variable hello that might have some numbers in it or something like that, right? It's not like you're doing hello is equal to 5 and then printing out hello and it gives you 5. Well, in this case, if you wanted to say exactly what you wanted to say, you have to use something called a string. So that just simply means putting that thing in quotes. So now Python goes, oh, you want me to say exactly hello like this, and it'll say hello. Now let's say I wanted to say print hello world, right? If I do space here, it's just going to give me an error. It's going to be like a variable with a space in between a variable. I have no idea what you mean. So now if you put both of these in quotes, it'll go, oh, you want the string that literally says hello world exactly like that. I understand. I got you. Let me do it for you. Okay, simple enough. Cool. That's it for strings. I'm going to keep it really simple. I'll see you in the next video. Okay, so this part now naturally leads us to fun functions. All right, so let's talk about that. All right, so what we have done so far has been really cool. We figured out how to draw a square, and we figured out how to write it as a Python script, so when we run it, it all runs at the same time instead of running it here one by one. We also learned about variables and strings. So in here, the thing that's a variable is my turtle, right? And then we keep using that variable over and over again. Let me ask you a simple question. In this program right here, is there a single string that we're using anywhere? Yes or no? What do you think? 3, 2, 1. There isn't any strings that we're using here, okay? What we are using here are integers, and integers are just whole numbers from negative infinity to positive infinity, right? So you have negative, you could have 100, 90, but if you have 90.2, that's not your, that's not an integer, right? That's something else, which we will discuss. But up to this point, I think that we are, this naturally leads us to functions. So let's talk about that. Notice that when this part of the code runs, what it does, right? This part of the code, I want you to just kind of memorize it for now. you're not going to really understand what it means until we get to object-oriented programming. But I want you to just focus on this part, and what does this part do? So let me simply run the code, and let's see what that part does once we run it. And it goes and it draws a square, right? So this part of the code draws the square. Okay, that's cool. What if we wanted to make, whenever we want to make a square, right? It seems like we would have to copy this code and write it again. So for example, let's say my turtle dot forward 100, and let's see what happens. I'm gonna save it and I'm gonna run it. Okay, so I'm gonna move it forward, and now I'm gonna try to like draw another square. So I'm just gonna copy paste that code. Oh, cool. It kind of looks like glasses or something, right? So let's go back. So this is a square, and this part is a square, right? So every time we have to draw a square, we have to copy this whole bunch of code and write it again and again every time. Well, think about this. Back when we were using variables, did we have to remember all of these numbers? No, we just stored it in X. So I'm going to teach you guys a trick where you can take this entire block of code and kind of give it a name, like a variable name almost. But it's a little bit different. And when you assign something to a block of code, it's called you put it in a function. Okay, so here it's all gonna make sense. So I'm gonna remove this up at the top. Oh, quick thing, just in case you guys don't know what this is. This is called a comment. Okay, anything that you write with a hashtag in front of it, you're telling Python to ignore that part. Okay, I don't want you guys to get confused by that. Okay, so for example, if I write hi here, it'll just ignore it. But if I write hi here, it'll give me like an error or something. So hashtag means I'm putting a comment and it's only for humans to read. So now let's turn it into a function. So I'm gonna say def, that means like define, and we're gonna define some function. So what does this thing do? It draws a square, right? So I think it would maybe make sense if we call this function a square. And whenever you create a function, you have to put open close parentheses after it, just like that, and put a colon, okay? And now everything that you want to make part of that function, you have to indent it. So what I'm gonna do is go here, hit tab, go here, hit tab, go here, hit tab, whoops. And then you can also just highlight that part of the code that you want to move and just hit tab all at once, okay? It'll move it for you. Now let's see what happens when we run this code. So I'm using the shortcut to run the code. That's weird. It's not really moving anywhere, right? Think to yourself, why is that happening? Okay, let me tell you this. If I wanted Bob, or let's say X, to be this number, right? And I want it to make X spit out that number, right? Print that number out to the screen. Well, if I define X to be something, that's not the part that does the spitting out. That's just me defining what X is, right? But the part that does the spitting out is when I actually say X and hit enter and it does something. So if I do banana is yellow, then if I want to say the yellow part, right, I would actually have to say banana and then it spits out yellow. Just like that, me defining a function doesn't call the function, doesn't actually use the function. So I actually have to call the function or use the function to make it do something and make it, like spit it out pretty much. So here, I'm gonna say square, okay? So like, if you were born and somebody gave you the name Jimmy, that's them giving you a name. They're not calling you Jimmy. They're not telling you to come over, Jimmy. They're just giving you a name, attaching that label onto you. Then later when they want to call you, they go, hey, Jimmy. And you're like, what's up, right? They're like, Jimmy, come here. And then you respond to them, okay? So just like that, we gave this function a name, square, and here we're calling it. So now let's see what happens. So I'm going to run this. Look at that, right? It made a square. Well, what does that mean? What if we wanted to do that same thing where we moved forward 100 and we wanted to make another square? So let's say I put this line, move forward 100. And then I want to make another square. How would I make another square? Should I copy all this code and then paste it right here? No. The trick is that I just call that function again that makes a square, right? So let me run it. Okay, how cool is that? So why do we create functions? Hopefully it's clear to you. We create a function so we can just reuse that code over and over again without having to write all of that stuff again and again and again, okay? To make it a little bit cooler, another thing I'll show you about functions in the next video is how we can give arguments to functions, okay, or parameters. So until then, I'll see you in the next video. So in the last video, we left off at talking about how to make a function. So we wrapped up our square in a function, and that way we were really easily able to use the square. And this way we can use the square as many times as we want, and it's very easy. So let's do something cool. So I said, let's talk about the idea of arguments or parameters in a function. So what we want to be able to do is, let's say that instead of 100, what if we wanted to move a different length every single time? So let's say we don't want to be boring and just move, I don't know, 100 steps. So let's take a look at it. Let's say we don't want to move, oh, I didn't call it anywhere. Let's call it again. And I'm going to remove this line here. Okay, let's run it. Okay, and let's say we don't want to be boring and make a really small square like this. Let's say we want to maybe go 200 steps, okay? So let's try it. Let's go 200, 200, 200, and 200, and let's take a look at what that looks like. Nice, the square looks better. Let's try to tweak it a little bit, and let's make it, I don't know, 240, 240, 240, 240. Let's see. That looks pretty cool. But what if I wanted the turtle to go all the way to that edge perfectly, and then go down, and then go to the left, and then come back up? Okay, let's try something. Let's try 280, 280, 280, 280. And hopefully, oh, it's still not hitting the exact. So maybe let's try 290 or something. So I hope that you're seeing that we have to change these values here a lot, right? We have to change it every single time, and we have to change all 4 of them in all of those locations, which is kind of annoying. So how can we make it so we don't have to constantly change all those values, you know, again and again? It's kind of really frustrating. So we want to make it so we just change it one time and it changes it everywhere. So let's say, I don't know, let's call it n. Okay, let's make it a variable that's the same everywhere. So let's just call it n. And I'm going to make a variable here, and I'm going to call it n. And I'm going to say go 250. Okay, so now everywhere n is, we have 250. Okay, so let's try to run this bad boy now. Okay, cool, 250. Let's make that really small. Let's say 50. Okay, that was really small. So that's pretty cool. We were able to use that, and that made our life really easy. But a lot of the times, we don't want to change the function itself, like the definition of the function. Here, its job is to make a square, and that's all it should need to know how to do. And we want to be able to give it something which, based on which it changes the length of it, right? So like how far it goes or how big the square is. Okay, maybe you can think of it like in English, if you have a definition of a word that you look up, once you learn that word, you can use it in whatever way you want, right? It really depends on the context. For example, if you want to say, wow, man, you really killed it, you're basically saying you did a really good job and you did amazing. Or if you said, oh man, you just really killed that thing for me. You know, you really killed it for me. I don't even find it fun anymore. Now you're using it, and now the context is basically that somebody really made something less enjoyable for you or discouraged you in some way. So the word kill in this case, right, it has a completely different meaning, but based on the context, we change it, right? Well, depending on what context we give it, we change the word kill. But we shouldn't actually go and change the definition of the word kill every time we want to use it in a different context, okay? So what I'm trying to say here is, instead of changing the function itself, let's do something really cool. Let's give it context, okay? So I'm going to say square takes in some input n. So whatever n I give it, it just puts that in here. And instead of calling it n, let's make it more fun and call it length. So everywhere I see n, I'm just going to replace it with length. So now the cool thing that's going to happen is, if I give it the length of 5, everywhere it sees length, it just replaces it with 5. If I give it the length of, let's say, I don't know, 200, it'll go everywhere and replace everything with 200. Okay, that way we'll get a longer square. So let's try it. If I run this right now, I'm going to get an error, and let's see why. Okay, I got an error, and the error says type error. The function square, right, that's what the parentheses afterwards it means, that is missing one required positional argument length. So we're supposed to give it something. We're supposed to give it context, right? Like the word kill, we gave it context and it changes the whole meaning of the thing. So here in square, we're going to give it the length. So let's say for length, we say 100. Okay, now let's see what happens. Let's run it. And we get a square that it goes 100 in each direction, right? So what just happened? We passed in the 100 here, which really passed in the 100 here, right? And since it was 100 here, it became 100 everywhere else. And so we got a square that was a size 100. And we can effectively do the same thing. If I give it 300, that's probably not even going to fit on the screen. Oh, it pretty much does. It makes a bigger square, right? So now the only place I have to change it is really here. This thing's job is to now just make a square. That's all it does. And here we can tell it how big that square should be. So let's say that we say make a square of 300, and then make a square that's I don't know, 150, and then make a square that's 100. Okay, let's see what that does. Let's see what that looks like. Okay, that's 300, that's the 150, and that's the 50. Whoa, that was cool, right? That kind of it seemed like it was about to make some kind of design right there. Okay, so hopefully you guys have a little bit more of an understanding of how arguments work. Just to take it maybe one step further, what if instead of these 90 degrees, you wanted to be able to change the degrees? Maybe we can go in here, and say angle, right? And replace everywhere we see 90 with angle. And so now we have to give our function not one, but two arguments, okay? So let's say 390. So the 300 will replace the length part. So everywhere there's length, it'll replace that with 300. And the 90 will replace angle. So everywhere it says angle, it'll replace that with 90. How cool is that? So let's run this bad boy and check it out what it looks like. We've seen the square before multiple times, 300. But now let's add a twist. Let's make this 45 degrees. Let's see what happens. I don't even know what it did. Let's reduce the length so we can at least see what it does, right? Let's run it. Whoa, that's kind of cool. It didn't make a square. It did something weird with it. Okay, so I'm foreshadowing multiple arguments, and in the next video, we'll talk more about it. All right, guys, I'll see you there. Okay, so now that we've talked a little bit about functions with their arguments and also a little bit about functions with multiple arguments, this naturally leads us to the next thing. What if I want to make that one square, but I want to make it multiple times? Sure, I can copy it and paste this line and paste it again, right? And then paste it again, so on and so forth. So for example, let's try having it pasted twice. I'm gonna remove these comments here. And just so you remember, this 50 goes in for the length. It replaces every part of the length with 50. This 90 goes for the angle. It replaces every angle with 90. That's how it works, okay? So let's go back real quick and simply run this now, okay? So I'm gonna hit the shortcut key to run it. And you can see I said draw two squares, and it did, yeah? But here is the concept. Here's the most amazing concept in programming, which is the concept of doing things over and over again, also known as loops. So if I said, I want you to do 10 push-ups, that's like a loop, okay? And every time you do a push-up, I count 1, 2, 3, 4. And then once you hit 10, I stop automatically, okay? So a way to say that here is you can say for push-up in range 10. So for each push-up, for 10 times, like do this. And this push-up part, I can call it whatever I want. I can call it this, I can call it I. We'll just keep it simple and leave it at one letter I. And what we're gonna do is this part, all this part says is run something 10 times, okay? That's what that part essentially says. If I run that code on the left hand side, if I show you what range of 10 gives me, it gives me this. So when I do range 10, it won't really show you, it kind of hides what it gives you, but in reality it gives you a list of 10 numbers, okay? So we're gonna talk about more things like lists and integers and floating points in our next video, but for now I just want you to think of it like it gives us 10 things, and so it runs 10 times. Okay, so if I did for I in range 10 and I said print I, what actually happens is the first time in this list, the first time you run through in this loop, I is 0. Then the next time, right, this range 10 is really this list here. So I is 0 the first time, then it's 1, then it's 2, then it's 3, then it's 4. And each time what happens in the loop is the part that's indented inside of the loop, that's the part that runs over and over and over again. So what happens? The first time I is 0, we say print 0 and we get the 0 right here. Then we say I is 1, so I is 1 over here, and then it says print 1, we get 1 over here. Then in the last one, I turns out to be 9, so we print 9, and then we get this 9 over here. Okay, that's a basic idea of how the loop works. So the part that we want to run over and over again, we're going to put it inside of this loop. Notice the colon at the end, very important. And I'm gonna put this part inside of the loop. And I don't even need to put that. I can just do this, and I can say I'm basically saying do this thing here, draw a square 4 times. That's all I'm saying, okay? And I will replace this code in the regular way without a loop, and I'll prove it to you. Okay, so first let's run it like this. Dang, that was cool, right? That was really freaking cool. It just ran that 4 times in a row. Now, I can show you what I mean, okay? And I'm gonna comment out these lines. And you can see it's gonna draw that same 4 squares that we just drew, okay? Just like that. But by using a loop, your code gets a lot more clear. What if you didn't want to run it 4 times? What if you wanted to run it 1,000,000 times? Yeah? It would be a lot harder to write that out 1,000,000 times, but it's really easy to write 1,000,000 in here. I think that's 1,000,000. That's 10, 100, 1,000, 10,000, 100,000, 1,000,000. That's actually 10 million. So there you go, 10 million. So this thing is gonna run 10 million times, right? If I ran it, I'm gonna close it and really quickly because it's gonna keep running forever. But you'll notice that it just keeps overlapping on the same squares, and it's gonna do that 10 million times. So if I went to sleep and woke up, this will probably still be happening, and then it'll still be happening after that. So let's exit that before something crazy happens. Okay, so that's loops for you guys. That is it for this video. I will see you in the next video. Hey guys, what's up? So in this video, I want to talk about primitive data types. Now we're getting into the adult programming stuff, okay? Getting out of a little bit of the baby stuff. Even though it's not baby, but you know, let's just admit it. So let's talk about primitive data types. What are they? Well, okay, so let's start off with like basic ones first, okay? And I also want to clarify something about variables for you guys. So you can't start a variable with a number, okay? So if you say 5 is equal to, I don't know, hello, right? The string hello, you're gonna get an error. So you gotta start it, you gotta start your variable with a letter. Now you also can't start it with symbols. You can't say something like this is equal to hello, okay? You're gonna get an error. You can combine underscores with your variables. You can say hi, hello, something like this, okay? And that would work for you. Okay, primitive data types, what are they? So if I have this thing in the green that you see, that is a string, all right? So in this video, I think we can just keep it like this, okay? So that's a string, hello. Anything with the quotes around it, and you can also put double quotes if you want. This is a string data type. Okay, this terminology is very important to remember. Then you have your integers. Integers are anything that is like this. Okay, 4.3, 4, 5, 2. Those are all your integers, obviously. Things that have decimal points in math are called decimal numbers. In Python, we call them floating numbers, okay? So you have floating numbers like 455.5, 354.90. Okay, these are your floating numbers. So that's another important thing to remember. So this was just a little primer on primitive data types, just so when I use this terminology, you guys don't get confused or like want to throw things at your screen, right? You're like, I don't know what he's talking about. Boom, just throw your like mouse or your socks. Don't do that. I'm telling you them what they are here, and feel free to look them up a little bit more so you can understand more about them. But this is some of the basic ones we're going to be dealing with, and in the next videos I'm going to talk about things like what is a list, what is a dictionary. So we're going to go over those as well, okay? Just to give you a little bit of foreshadowing into it for you advanced people there. You want to learn more, right? You want to overachieve. list is basically something that holds multiple things at once. So for example, I can say banana and apple and oranges like this, right? And at the start, I can say x is equal to, I hate x, I hate one letter variables, and most Python people do as well, because it's usually a sign of bad coding. Always try to make your names very relevant. Get into that habit right now. Promise yourself, cross your heart. I don't care what you have to do, but work hard on variable naming, even if it slows you down sometimes, okay? So no X, no Y, only if you have to. It's gonna make your code really hard to read, and when you're reasoning through your logic, you're gonna not understand what you were doing. So let's say, I don't know, fruits is a good variable name, fruits. And now if I call fruits, you see a list of that thing. Okay, I was talking about primitive data types, but I got ahead of myself. I started talking about some data structures like a list and dictionaries. We'll cover all that later. Be patient. I'll see you guys in the next video. There, my beautiful children. In this video, we're going to talk about string slicing. What is string slicing? We're not talking about cake slicing, so let's get started. Well, a string, as you remember, was that thing in the green here, but that's just really specific to the idle that we're using. If you're using any other text editor, it's not necessarily going to be green. So the string is just something in quotes. Either it's single quotes or double quotes, as long as it's consistent. You can't have a single quote ending with a double quote. They gotta match, okay? So we have to match with the quotes. That's your string, right? So what we want to do now is slice those strings. Well, what does that mean? Imagine I gave you an email address. Email is equal to, I don't know, rafe@gmail.com, something like that. Well, a common thing that people have to do when they are getting this data back is, well, this is the username or something. This part is the Gmail thing. And then this is the .com part, right? So like, let's say we just want the domain or whatever. And here we simply want like the username. So how would we do that? Well, we can use a little bit of string slicing. So let's just start with a simple example. Let's take hello, and let's say we want to get the first letter from hello. We want to get just the H. Well, how you do it is you index by opening a bracket and closing a square bracket. And if I do 0, it'll get me the first letter of that, okay? So H in this case is 0. Right? The E is 1. In Python, most of the things start from 0. So we go all the way up to this O here, which is a 4. Okay? So we take this hello and, whoops, let's take this hello and let's simply do 1, and that'll give me the E. Okay? Now another thing I want to show you guys in string slicing, besides doing, okay, that index, right, this passing in the index 1 will give me the second letter. What if we want to do something cooler, like get a chunk of code? Well, how indexing works is it's start, colon, stop. Okay, colon, stop. So what you can do is you can say hello. Oh, I keep doing that. Hello, and you can say start from 0 and end at 2. Not including 2, but end at 2. So include 0, but don't include the 2, which means that you really get the 0th index and the first index, right? So whatever the letter is at the 0th index, and then whatever the letter is at the first index. So in this case, we'll get an HE, okay? How you can read this is just give me the first 2 letters. That's how I read it. So you can just say, give me the first 2 letters. Now, when you're starting off from 0, by default, index starts at 0. So if you actually don't say this at all and you just remove the 0, you're going to get back HE. Okay? Everything that I'm showing you guys here, play around with it, okay? Don't just sit here and watch my videos. I don't want you to be a passive learner. Please, please actively do this with me, or pause my video and do this. I want you to spend more time doing and less time looking at it, okay? Because it seems really simple when you're watching it, but if you don't put into action and do things that make sense to you, if you don't turn it like into a game for yourself where you're doing something, you know, like making fun little stupid projects using what I'm showing you, you're not going to be able to remember it. That's really what my problem with Codecademy is. A lot of people go through Codecademy, but the problem that ends up happening is that they just go through it at a really fast pace, and they don't really have much projects that they get to do there, and not a lot of stuff that they get to do on their own. So the most common complaint you hear from people who take the Codecademy course are like, it was great, I took the whole thing, but yeah, right now I can't write a single line of code. Okay, so it's not impressive the higher you are in really abstract levels, introduction to classes. Oh yeah, I know all about functions. I'm in introduction to classes. Write a function. Write a function that takes in 3 inputs and does prints something out in sorted order. I don't know how to do that. I'm totally lost, right? Don't be one of those people. Make sure you build strong fundamentals and your coding level is functional at all times, right? So even if I'm teaching you really basic stuff, make sure you can do something with it. That's the only way you'll get better, and make sure you have fun while you're doing it. Anyways, let's get back to it. So, hello, right? Make up your own strings and break them up and see what you can make up from what I've just shown you here. And experiment. What if I change the end? What if I change the stop part of it? And what if I change the start part of it? What if I don't put anything in the stop part? What happens? So let's try that. So hello, and let's put in nothing for both parts. Let's see what happens. You just get the whole string. By default, it starts from 0, and by default, it ends at the last index. Okay, so it's the same thing as saying 0 to, if you count it up, 0, 1, 2, 3, 4, right? O is 4, so I'll say 4 here. That will not give me it. I have to say 5. Right? Because it will not include the 4. If I say 4, it'll go up to but won't include the 4. For example, see? So we have to do 5. Okay? So that helps us get to the end of the string. Now, what if I want to get the last letter from hello or anything? If I want to get the last letter, I can do something like this. Negative. Okay, I can also slice by a negative number. So if I want to get hell from hello, I can do hello, and I can say go from 0, and let's try and see what happens if I put -1 here. Right? So another way, basically what I'm saying is start from the 0th part, go up to the last part, but not including the last part. So that gave me hell. Another way to write it is by putting a 4 here. Okay? Another way to write it is not having a 0 here. Another way to write this is not having a 0 here. That all gives you hell. So you see, play around with all those. I'm gonna now show you another thing that you can slice with, and that'll also blow your mind. Slicing is very important. It's a very common procedure, so it's pretty good to learn it because, like, let's say you were trying to make an app which goes on Craigslist and pulls a lot of data from Craigslist, so it'll like pull up ads. So the ad, like, you might get the data back in a string form. So you might get something like Xbox 360 pricing is its price is $10 and. Or that's stupid. It's not $10, right? You might get it for $150 nowadays. It's 2016, so the value of it has significantly dropped. And then let's say it says the condition type. So the condition type is new, right? So this is the data that you get from Craigslist. Well, if you were writing a script or Python code that would pull that information and then make sense out of it for you, and like write it to an actual Excel file. So like you want it to, you know, essentially do something cool where it opens up Excel and writes to it, and you want it to like have, you know, product, price, and condition, right? And in product you want Xbox 360, in price you want 150, and in condition you want new, right? How would you pull that data cleanly so it doesn't put Xbox 360, 150, new all in one place, right? So for that, you need to be able to do string slicing, okay? So for instance, you might say console or product, right? Our column called product is equal to, you know, find me the first pipe, right? So like, let's say we have this guy here. There is a method you can do on data, which is called index. So let's find the index of pipe. It tells me that pipe is at index 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Which means that if I index the string data and I do 9, it'll give me back the pipe. So what that tells me is that to get Xbox 360, I need to go from the start of that string all the way up to the first pipe. That should get me the product. So I can say product is equal to data from the start. I don't need to say 0, right? I can say from the start to take the data dot index of the pipe. And now if I show you product, boom, look at that, we got Xbox 360. And so now I can write that product to the file. I'll teach you guys how to read and write to files. Okay, so then what it will do is that it'll actually write Xbox 360 in here for you automatically. Now, understand the power and implications. Well, why can't I just do that by hand, right? That might be your question. What if it was 100,000 products? Can't do it by hand. Good luck, right? What if it was 1 million products that you were trying to search from and find the best price using your Craigslist bot? That's where programming comes in, okay? It's very important to understand how programming in here ties together and how it's more powerful than you trying to do this on your own. So that's really the power of string slicing, okay? To break this line down for you a little bit more, data, colon, that's just saying start from 0, and then I'm saying data.index of pipe. What does that part evaluate to, right? Dot index is a method that you can use on data. That's okay, which just gives you something that you're looking for. You pass it into the function, right? That function or that method index takes in one argument. So what does this whole part evaluate to in our case? This part evaluates to a 9, right? This whole part, data.index, right? It evaluates to a 9. So if I do data 0 through 9, you can see that I just get Xbox 360 the same way. 9 tells me up to but not including the pipe, okay? So that's how we got the Xbox 360 part. How would you get the 150? You would kind of do the same way to get the price, okay? But you would say, instead of starting to look from here, because then it'll find this pipe right here, right? This one. You want to find this pipe now. So you want to actually start your string search from this location or this location that I'm highlighting. And then you want to search all the way up to this pipe and stop there and get whatever is in between these two pipes. Okay? So that's something that I want you guys to try. Paste your code below for how you might get the price and the condition. Okay, that would be a fun thing for you guys to do. I'm going to keep moving on and talk a little bit more about strings and string slicing because there's still a little bit more to it. So, and again, I want you to keep practicing all this, right? Because otherwise this is going to overwhelm you, all this knowledge. So let's say that I have, I can do start, stop, and here's another method to blow your mind, step. So how many steps do I want to take when I'm reading something? Okay, so like let's say I have this string, hi, how are you doing? It is very nice to meet you. I want to make sure I'm consistent, so not double quote, single quote. And you know, let's just store that in some variable greeting. Okay, so if I say greeting, you can see that whole string. So what I can do is take greeting, say start at 0, stop at, I don't know, -1, so like all the way at the end, and then I want you to basically it'll go up to O, right? Because it's up to like, or sorry, it'll go up to the U part, but not this period right here. Sorry, I just it won't let me highlight that period. It won't go up to that period. Okay, it'll go up to U because it's up to but not including the period. Sorry, I keep saying that a lot, but I do know that when you're starting to learn Python or programming, those things you'll forget a lot. So I'm sorry if I'm reiterating that fact over and over again. All right, so we start from 0, we go up to the U, right? We go from here all the way to here, and then we want to step. So instead of, for example, taking, I don't know, reading every single one of these, we can read every other letter. So I can say, instead of stepping by 1, which is default, if I do 1 here, you'll see this pretty much the same string without the period. And if I do nothing here, you'll see the same thing, right? Because that's the default. And if I do step by 2, this is basically saying give me every other letter. Okay, so think about maybe creating a game, gibberish game, that takes in a string as in a, like it's a function called gibberish, takes in a string and it just gibberishizes it. Okay, it just like jumbles it up. And if I do 3 here, you can see now it's stepping by 3. All right, so pretty weird, but it's also cool at the same time. And another thing that I want to ask you guys as a practice to do before I end this video is, say I had the string hello. I gave you the string. How would you reverse it? Okay, I want, if I gave you hello, I want back ole. Or if I gave you ole, you should give me back hello. Okay, so hopefully that blew up your mind on string slicing. I'll try to put some exercises on cleverprogrammer.com, so if you haven't already, go enroll into the school, and there will be exercises and extra resources that you can use to get help. Also, there are others in the community who can help you. Okay, so good place to go for help. But if you're watching it on YouTube, that's totally fine. Comment in the YouTube section below, and I will personally try to help you out. Other than that, I'll see you guys in the next video. Hey guys, what's up? So in the last video, I talked about string slicing. In this video, I'm going to talk about lists, okay? Lists of things, and what the heck are lists? Lists are awesome. However, in the last video, I left you guys with a question. I said, take this, right, and parse it, and basically Xbox 360, pull that out, save it in a variable like product, pull this out, save it in a variable like price, and save this in a variable like condition, right? So when you have your Excel sheet open, it looks really nice. It'll look like this. Okay, so I'm in my solution, I'm gonna do it in a different way, because if you try to use it as index, this is the solution. So you can pause the video, think about how it works. That's how you'll pull the 150, and using the same logic, you'll pull new. However, index is a very ugly method to use for parsing the string. What I want to show you guys is this method called find. Okay, that's a very nice method. So like, let's say we take the data, right? And I do data.find. And find, it shows you at the bottom what it takes in as the function. It takes in the substring, and then it takes in optional arguments like start and end. So I'm gonna say data.find, and I'll give it a substring pipe. What a substring means is that that's something that exists in the original string, okay? So for example, I have to give find, the function find or the method find, I have to give it something that exists within this. If I gave it something that doesn't exist within it, like banana, it would say -1, like I didn't find anything. But if I gave it a pipe, you can see that it finds a 9. And another thing you can give it is how you saw is you can give it where to start from. Okay, so I can say, like for example, start looking after 10, or look for pipe, but I want you to start at string 9. Okay, or I want you to start at string 10. All right, and now it finds a pipe at location 15. So if I do data, and if you count it up, you'll see that this is the pipe, and it is at indeed location 15. If I do data of 15, you'll see that it gives you back that pipe, right? Okay, so by getting that second pipe, now you can get the value in between the first pipe and the second pipe by saying something like, start from finding the first pipe and then go up to finding the second pipe, right? So I can say finding, or start from, or look for pipe, and then start from 10, for example, right? And this gives you this guy here. And just to make sure we don't include the pipe in the first one, we can just say start from +1 of that. Okay, so that gives you in between the first and second pipe, you get back 150. Okay, so the reason why I went even more in depth in strings, even in the video called lists, is because a lot of what you learn from strings is applicable to lists. Okay, so let's take a list and call it groceries. And I will have apple, and I foreshadowed this for you guys a little bit, banana, and it can also have integers, though usually you try to put the same kind of thing in the list. But sure, let's put 5 in there and 6 in there, and then oranges or something, okay? Cool. Now, if I wanna take this list and I wanna get the first element and the second element, if it was just a string, right? Like the reason why lists are useful is because you can use it to store multiple variables. Like for example, if you wanted to use variables to store this, it would be a little, it would be weird because you will say groceries 0 is equal to apple. You would say groceries of 1 are banana, and so then when you do groceries of 0, you get back apple, and when you do groceries of 1, you get back banana. But lists make that thing for you in a really easy way, okay? So now if I do groceries, and if I do groceries of 0, I get back apple, okay? And if I do groceries of 1, I get back banana. Because apple is in the 0th position, banana is in the 1st position, this is in the 2nd, 3rd, 4th position, okay? So lists make it really nice for you. Imagine if you were trying to store a data for a race, so like 4 of your friends ran really fast, and you wanted to record who came first, who came second, so you can say race is equal to like John came first, and then Bob came second, and then, you know, whatever, like Timothy came in third. Timothy is pretty slow. So we can say like, okay, who came in first? We can ask that question. We get back John. We can say who came in second. We get back Bob. And I can say who came in third. Or I can say who came in last. Like -1 gets you the last element. And this answers all my questions. So just like how we were able to slice strings, we're able to slice lists, okay? But notice lists is nicer for elements. So for example, Xbox 360 and all this stuff, I'll show you guys a really cool trick you can do with lists to break that up into pieces. So like for example, if I gave you a string like this, right? What is going on? Notice that there are a lot of spaces in between, right? Let's just replace those spaces, just so it's more visual. Let's replace those spaces with that. And let's say we want to get the what part separately, is part separately, going part separately, and on part separately without having any of the dashes in the middle. There's a method we can use called dot split, okay? And we can pass to dot split what we want to split by. So I can say something like this. I want to split by the dashes, okay? So check it out. Now I got what is going on, right? This is a list of strings. Now the data complexity is getting a little bit higher, right? It's a list containing strings inside of it. Okay, so I can call this like, you know, greeting or something, doesn't matter. And if I do greeting, I can say what's the first word of greeting, what's the second word, whoops, greeting, right? What's the second word? And for example, I can say what's the last word, and it'll give me what is going on being the last word, right? Now I can also do string slicing just like how I can do in strings. So I have start, I have stop, and I have step. So if I take the race one again, I can say go from 0 all the way to the end. I can say the same way like this. This is like optional, right? 0, it starts from 0 and it ends at 0, or ends at the last one by default. If I want to get from John to Bob, I can say like, give me the first two first two contestants of the race, and it'll give me John and Bob. Or I'll say, give me everybody but the last guy. So I can ask that question to my list just like that. Okay, now to answer your guys' question of how to reverse a string, it's the same way you can reverse a list as well. So let me show you guys. There are a couple of different ways, but I'm going to show you guys the nicest, the fanciest way, okay? So let's take this list, and I want to I want to start at the default, which is 0, okay? I don't have to write it 0, but I'll just write it for you guys. I want to go all the way to the end, and I don't have to write this, okay? So I'll just leave it blank here. And for the last part, for step, instead of saying step by 1, which will just give me the whole thing, and instead of saying give me every other element, so like give me John and then Timothy, I will say step by -1. So check this out. Let's remove this, right? And let's remove that guy, and let's do that, and you will see how it steps, right? It just reversed the list. If we have the same string, like let's say we have data, I can do the same way and reverse everything in data. So you can see Xbox 360 and new and 150 are all written backwards, okay? So that's how you would like reverse something. Now I want to talk about split again, and I want to talk about one very important method called append for a list. One of the most commonly used things that any programmer does in any language. Okay, so split is like Java, C, everybody uses that. It might not be called split. And then same thing in Python, everybody uses split. And the next method I'm about to show you, append, very common for all the games you make, for everything that you do. It's going to be like one of the most common things you use, especially append. So pay attention. So I'm going to show you the method called the split. Okay, so I've shown you a little bit of that already. So let's say I take data and I want to break it up, right? Product, price, condition. Very easy way to do it. Very easy way to do it, split. So let's do data dot split, and I want to say split by pipe. Boom, look at that. How nice is that, right? It automatically just split it by that, and you can store that in details or something. And now if I do details of 0, right, and I can set that equal to product. So now if I do product, I get that. I can say price is equal to details of 1, and I can say condition is equal to details of 2. Okay, price, condition, boom. Okay, so that was like some really nice ways to get this done. In the next video, I will talk about append, so stay tuned. So in this video, we are going to talk about how append works in a list, because the last video got a little bit long. But for those of you who want their minds blown, I want to even give you a better solution for the problem with the whole splitting thing and then storing it as a product, price, and condition. So remember, we had data, Xbox 360, product, 150, price, condition, new. There's even an easier way to do it. I can say product, I can say comma price, and I can say condition, and check this magic out. And I'm gonna say data dot split that by pipe, and boom, we're done. So now product is the first element from that list, right? If I show you data dot split by pipe, what you get is first element, second element, third element. So the first element maps to this product, right? This product right there. Price ends up mapping itself to 150. Condition ends up mapping itself to new. So go check it out. It's also kind of known as the concept of tuple unpacking. Really, really advanced concept. We're not going to get to it till maybe an intermediate or advanced course. But yeah, just something a little fun to blow your mind, and look at how efficient Python lets you do things, right? Efficiently. So really simple way. But hopefully this shows you the power of how you can combine lists with the whole idea of slicing and all that. Now, one of the most common things I want to show you is this whole thing called dot append. Okay, it's a method that you can use on a list. Very common method, and this is one of the reasons why lists are a lot more useful than strings or any other thing. Okay. Oh, let me just be clear. It's not that strings are not useful or lists are more useful, but the reason why lists are so awesome is because of that. That's what makes them unique. Okay. So let me give you some list with sure, let's give you erasers, or let's do something simple. Let's do numbers. Okay. Now, there's a really easy way to grow this list. So I want to keep adding some numbers to this list. Well, how do I do that? What if I want to add some number to this list? I know how to access each of these numbers. I know how to slice each of these numbers and get a range. I know how to step and slice and get ranges at the same time. I know how to reverse the list. But what if I want to add more things into the list or change existing things in the list? Well, to add things in the list, we use dot append. Okay, append meaning add something to the end, hence append. Prepend, add something to the beginning. So we want to add something right over here in front of the 5. So let me do 6, and if I show you numbers, and now you have a bigger list. Let's say I wanted to add another thing. I'll just say append 7. Now if I show you numbers, now the numbers has grown bigger. You got 7. All right, so We're using this new app that you're creating where once your friends raced, you put them in the list. But let's say more of your friends get excited. They're like, wow, this app is amazing. We want to race too, so you can put us in there. But you're like, the list only takes in 3 people. Well, append lets you add in more people, right? So you store that data, you keep it there, and then you use append to add more of your friends into the list. What's also nicer is you can use a loop to add things into the list. Okay, so for example, I can say for I in range 100, if I say print I, well, what is that gonna do? It's gonna go all the way and print up to 100. Okay, so I'm gonna stop this right here, but you get the point. It's basically range, right? What is range? Just to show you range of 10, that's effectively just a list 10. Okay, and then we kind of go through it and we print out each of those numbers. I'm gonna get more into loops in the later video, but this is just to give you guys a little bit of an idea of how we use lists. So for example, every time first time I is 0, then I is 1, then I is 2, then I is 3, and we keep doing that, right? So what can I say? I can say, because effectively, right, since this is a list, now I can explain to you guys a little bit more about loops. Since range is really just a list, right? I'm calling list on it because in Python 3 they hide it from you, and you'll learn why later. But if I call list on it, it shows me what range 10 looks like. And range 10 happens to just be a list. And list is what allows you to make that for loop, okay, that you've been making when you were creating your original Turtle games. So what happens is that the first time going through this list, right, let's just make a smaller list here for now. When we're going through the loop, I is 0 the first time. And then we call the print function right here, right? So I is 0 the first time, and then we print 0. Then I is 1 because it's the second element from the list. And so then we print 1 out to the screen. Then I is 2. And then you get 2 here. And then we print out 2 at the bottom. Okay, so that's how loop runs, right? The indented code keeps running over and over again. So that's really what allows you to do a loop. It's actually a secret list in the background. And so that's why you go from 0 to 100 here, right? Now, if I wanted to take that list that I had at the top called numbers and keep adding a lot of numbers to it, say up to 30, instead of keep having to manually do it, well, here's a nice way to do it. I can say for I in range, let's see, 14, or let's say, I want to start my range, okay? So if I just showed you, you can also give a start and a stop to range. So let's say I want to start my range from 8 and go up to, but not including 20 or 21. So I go from 8 to 20, right? So these are the numbers I want to add, okay? So let's do for number in range 8 and 21. And I'm not using I'm using the variable number, just so you guys know that you don't have to use, I is not some magical built-in thing that you have to use. Use a variable that makes more sense. In this case, since I'm going through looping and it's really numbers, and now you guys know that I turns into a number, it just makes more sense to call it a number. So then you're like, oh yeah, this will just be 8 the first time, then it'll be 9, then it'll be 10, then it'll be 11, and then it'll be 12, right? So let's go back. So let's replace this with just number. And then let's say numbers.append, and to the numbers list, I want to keep appending each number. Okay, so the first time I'm going to append, number is going to be 8, so then I'm going to append 8, and so it's going to add 8 to my numbers list. Then number is going to be 9, and then is going to append 9 here. Then number is going to be 10, is going to go append a 10. Okay, so let's do it like this. Let's replace this bad boy with number. Let's run it. Let's take a look at our list, and voila, you see it goes from 1 and all the way to 20. Okay, and if these were your friends and we wanted to see, you know, in the reverse order, like from losers to winners instead of winners to losers in a race, I would be able to do simply this trick, which says start by default, stop by default, and then step by -1. So that answers that question, right? Okay, cool. So a lot of stuff, but hopefully it's making sense, and hopefully lists are making more sense, and append is making more sense, right? Append is one of the most useful things. So I want you to remember append, and we'll come back to it and we'll probably build more things with it, okay? I'll have a project for you guys as well, where you're gonna get to practice it more. For now, come up with something cool, whatever silly idea or a fun idea that you have, code it up, something simple, post it in the comments below in the YouTube one or my website here, okay? cleverprogrammer.com. Either way, it's fine. All right, guys, I'll see you in the next video. Hey guys, what's up? This is Kazi. So in this video, I want to talk about a project, all right? So we learned a little bit about loops and how we can do some cool loops and make squares. We learned about functions and how you can give multiple arguments to functions. We did all of this while visualizing the code. That's why we use the Turtle Python module, so you can learn visually. No matter how old you are, no matter how young you are, visual learning is one of the best ways to learn. And to visualize your code, it's amazing because you get it right away. Now, I wanna take this time and now allow you guys to do an actual project. So up to this point, we did a lot of fun stuff and I gave you some basic exercises like make a square. Now I wanna give you a little bit of a project. It might take you long, it might not take you that long. It's not that much code at all. It's you just have to put a lot of these ideas together. Here's the project. I want you to make a circle out of squares. What do I mean? Just to be clear about what you need to do in the project and how it should look like, I've designed this demo for you guys, so check it out. Make a square, turn a little bit. 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 Okay? You get the idea? You keep going like this, and eventually you get a circle. And if you notice, and if you look really into it, you can probably keep looking at this forever. It's fascinating. So I love this thing. I can myself look at it forever. Yeah. Pretty enjoyable. Okay, so I'm gonna stop it right here. You guys now have fun with it. Try to make something like this, okay? It's not too complicated. It's really simple. Make a square, turn, make a square, turn. It just helps you put all the programming concepts we've learned so far. Variables, using the Turtle module, the looping structures, and arguments in functions, and the range thing that we looked at in a loop. So good luck, and I think you can do it. All right, I will see you in the next video where I'll provide you with the solution. Okay, in the last video, I proposed a challenge to you. Make a circle out of squares. So hopefully you gave it a try. Hopefully you put it in the comments below, okay? So if you're watching this video right now, whatever you got, I don't care if it's crap, I don't care what it is, I want you to put it in the comments below, okay? So whether you go to my website at cleverprogrammer.com and put it in Learn Python for Beginners, we have a comment section. So for example, you can go into one of these videos. I'm gonna have this video up there as well when you guys come to watch. I want you to put your code in the comments below. I will look at it personally, and one of our members will also look at it, okay? So right over here. Or you can just put it on the YouTube channel. That's totally fine as well, all right? So let's get to it. First of all, what I wanna do is, I have the square function, which is really cool, but it's really repetitive, right? It does, I mean, if you can see, all a square is you move forward and you turn right and you repeat that 4 times, right? So why do we have it here like this. This is really bad. There's a lot of redundancy in our logic, right? Like if you were telling your sister, your brother, your dad, your friend, whoever, these steps, you would be like, move forward, turn right, and then do that 4 times. That's how you would tell it to them, okay? You wouldn't say move forward, turn right, move forward, turn right, move forward, and then turn right, and oh yeah, move forward and turn right, right? So you wouldn't do that. So if we look at this, actually, we're doing this step once here, then we're doing the same step twice here, then we're doing the same step 3 times here, and we're doing the same step 4 times here. What does that mean when we're doing something over and over again? Well, it sounds like a loop. So I want this thing to happen 4 times. How do I say do something 4 times in Python? I just say for something in range. So I'll say for I in range 4. That's it. This will do that thing 4 times, and I'll simply go here and remove that code. Okay, so already our code looks much nicer, and that's a way better way of making a square. Okay, so notice it still takes length and angle. So if we're making a function, we need to pass those variables, length and angle, right? So then length here and angle here can become those. So we want, like, let's say length to be 100 and our angle to be 90 degrees. So square makes a square. Let's verify our hypothesis here. And remember, this function, all functions, you got to put open close parentheses after them. And you got to pass in an argument for this function here. So we're going to say 100 for the length, and I'm going to say 90 for the angle. Okay, I can also say it like this, just so the code is, you know, more clear what it's doing. Okay, I can say it like that, but let's keep it short and sweet here. Let's run it, and that should make a square, right? It made a square. Great. Now what we're gonna do is, well, we want to keep making squares, right? So we know we're gonna put it in some kind of loop. Let's say we want to do it 100 times, okay? All right, so I'm gonna put it in a loop because I want to make a lot of squares, and each time I make a square I want to turn. So let me first get out of this loop, and let me do this. Let me say my turtle dot right 90 degrees. Okay, and let me do this now, and you'll see that as soon as I make that, I turn a little bit. Actually, not 90 degrees. Let's turn, I don't know, 10 degrees. 90 degrees is silly. So I make a square and then I turn just like that. I'm ready to make another square. So let's do that. Let's make another square right here. I make a square, I turn a little bit, I make another square. Okay, you get the idea? Now we need this process to repeat a lot of times. So we need to make a square and we need to turn right? So it's really this step, and we want to do it again and again and again and again. So sounds like we need to put it in a loop. Let me uncomment that line, hit tab to indent it under the for loop so it knows it's a part of a for loop. This variable here does not need to be called I. By convention in the world of Python, we usually call it I. You can call it bananas, you can call it that, you can call it an underscore, you can call it whatever you want, okay? Just a little bit about variables. Variables can't start with the number like 5 or something, okay? So, perfect. This looks pretty good. Let's give it a try. Okay, I make a square, I turn a little bit, I make another square, I turn a little bit, I make another square, I turn a little bit. Beautiful, that's looking really good. Let me close this. Let me make the speed really fast. So let me make this, say turtle.speed 0, and that makes it run really, really fast. So it's going and going and going and going and going and going and going. But now notice the problem. It's not drawing anything new, but it's moving. So it's moving a lot, but it's not making anything new. Where does it stop making new things? Let's check it out. Let's say we want to do this how many times? Let's say we want to do this 30, or let's say we want to do this loop 40 times. Let's check it out. So let's see where it stops making it new. So the last 4 times it ran, you guys probably didn't catch it, but the last 4 times it ran, it actually didn't make anything new. So the 37th time it ran, it didn't make anything new. 38th time, 39th time, and 40th time. So what the heck happened? Well, here's what happened. 360 degrees, right? That's the number of degrees in a circle. So a circle has 360 degrees. Now we want to make the circle like really nice and dense. We don't want it to be how it was. Our circle looked pretty empty. And the reason is, okay, so the circle has 360 degrees. Now, if we're turning 10 degrees every single time, right? What's 360 divided by 10? That's how many times we can go in a direction if we turn right only 10 degrees. Is 360 divisible by 10? And the answer is yes. And the answer is actually 36. Right? 360 divided by 10. Obviously, you don't have to be a math genius to know that, but you get back 36, which means 10 perfectly goes into 360. And isn't that awesome? That's the number of times you can actually make unique squares if you choose 10 degrees. It's beautiful seeing divisibility in visualization. So even math starts to become beautiful when you put it in terms of computer programming, you guys. This was one of my most favorite discoveries, and I still get excited when I think about this. So I think that's pretty freaking awesome. What can we do? Well, pick a number that is not divisible, right? That 360 is not divisible by. So how about a great number? I don't know, like a prime number. And what's a prime number that's really close to 10? 11. So let's pick 11, right? Because 360 divided by 11 gives you something that's not divisible, right? Like 360 is not divisible by 11. 11 is a prime number. So let's run this bad boy and check it out. And let's run it 100 times, right? Not 40, 100 times. And let's check it out. It's turning 11 degrees every time it makes a square. You'll notice that it almost never repeats itself. And it'll probably never repeat itself, and it just keeps making the circle darker and darker and darker and denser, and that's how you want it, right? Look at how beautiful that looks. Dark in the middle, and starts to get lighter on the outer edges, and those webs are interweaving, and it's gorgeous, right? Bonus project I can give you guys for this is bring some colors out, make some cool designs. Go look up Trinket.io. Go to that website, check it out. Look at some examples. Paste your code below. You can help out other people. I can help you out if I look at your code, you have some errors, or it looks really cool and maybe I can help you make it look even better. Or maybe you'll just make something that'll blow my mind because I haven't made such beautiful circles out of squares. Anyways, I hope you guys enjoyed it. I hope it makes sense. Please like the video, subscribe. I'll see you in the next lesson. Hey guys, how's it going? So in the last video, we talked about doing projects, right? So we went over the solutions of some projects. In this video, what I want to talk about is dictionaries. They're very important in a lot of programming languages. In other ones, in C, C++, it might be called maps. In Python, it's called a dictionary. So let's see what it is about. Okay, so essentially the idea behind dictionaries is to map keys to values. Hopefully that defines everything, right? No, basically that's a very cryptic definition that I gave you if you don't know what it is. It maps two things, okay? So anytime you have a relationship between two things, you want to use dictionaries. And when you don't have a relationship between two things, you want to use a list. For example, if you want to just remember a bunch of numbers and that's all you care about, you want to use a list, okay? So for example, I only care about a bunch of numbers like this. I want to use a list. Now, what if I want to know a way where, I don't know, I use my cell phone, right? I use this thing over here, and using this thing, I can look up a person's name, and based on that person's name, it gives me back their phone number, right? Or if I type in their phone number, it kind of goes the other way around, whatever. How can we do that? Well, that's the beauty of dictionaries, my friend. So you're going to learn something very powerful today. So let's go at it. Let's say I wanted to make a phone book, right? With what we know in lists, I mean, can you think of a way how you might do it? I don't know. I mean, you could store numbers, right, like this as a string, and then store the second number as a string and go 456 22 4433, right? Something like that, whatever. These are clearly very silly numbers, but okay. And then you can say phone book and give me the 0th number, phone book, give me the first number. Also notice we're using something different for coding. We're using REPL.it, right? So it's actually spelled REPL.it. And the beauty of this is that it teaches you how to code while it makes it very easy for you to code. You can use this without having an actual working environment locally downloaded onto your computer. You can just run your code on the fly. And what I'm going to do for you guys is once I'm done with this session, I'm going to take this link and paste it into the YouTube description. And that way you can actually get access to these notes directly. Okay, so you'll be able to come to this link and get, for example, the link right now is this. Okay, but by the time we're done with this video, the link might be different, and I'll post the most updated link for you guys in the YouTube description. Okay, so the website is repl.it, and you can pick programming language Python for your programming language, and then just code here. Okay, so let's check out what this does. Let's make sure to add print. Let's check it out. So you can see you have 1, 2, 3, and 4, 5, 6, right? You're printing out the 0th element and then the first element of this list. That's great, but I mean, it's not really fun to remember names as numbers, right? Because you're not gonna go, oh, I'm gonna call you 0, Johnny, and I'm gonna call you 1, Bob. And then every time you have to look at Johnny's number, you're gonna type in 0 to get back Johnny's number or 1 to get Bob's number. That would be terrible. And what if you had stored hundreds of people in your list? Then it gets really complicated. But now let's use dictionaries. Here's how dictionaries work. Okay, let me describe right here in notes. Dictionaries. Okay, here's how they work. You have some dictionary. We will call it dict. Okay, and the store key value pairs. So if you put in a key, it gives you back the value. Okay, and how you store things into a dictionary is like so. Your key goes here and your value goes here. Okay, let's say key 1, value 1. Then we can say key 2, value 2. Okay, and you can keep doing this all day. All right, now let's create a dictionary. Okay, so let's create our example phone book. So I'm going to say Kazi, which is my name, which is my last name, but I go by my last name pretty much everywhere. So we're going to take the string Kazi as the, Kazi is the what? Is that the key or the value? If you said key, good job. And we're going to store the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Now notice that I'm storing this as a string and not an actual number, like an integer or something. Why do you think that is? Well, think about it. If I remove the quotes from here, what is this going to do? It's going to do 1, 2, 3 minus 4, 5, 6 minus 7, 8, 9, 0. And I'm going to end up getting back negative 8,223. So it's actually going to end up storing it like this. That's not what I want. I want the exact number. So usually when you want things exactly how they are, strings are perfectly good data type to use there. And now I'm gonna say Bob, and I'm gonna store Bob's number as okay, is this which key is this? This is the second key, and now this is gonna be the second value. I'm gonna store his number as 222, 222, and 2222. Very easy number that Bob has. He gets tons of wrong calls, and he gets very annoyed. Now, to make it a little bit nicer on me to read this dictionary, sure, I can have it as a long one line, but as you can imagine, as we begin to store multiple people, it's going to be spilling over to the right side. So what I want to do is make it easier on my eyes and make it easier to type. So I'm going to go to the start of the line, hit enter, and Python knows what to do with it and where to put it. And I'm going to go to the start of this line and hit enter. Okay. I'm also going to go here and hit enter. And I'm going to go here and hit enter. Okay. And what this does for me is it just makes it easier for me to read. Okay. Kind of like this. And I can just simply start putting things in here. We can leave that here, there. That's not a problem. We can leave that one right up there. And I can put in another person, right? Cat, cat, cat. Let's just do cat. Call her cat. Let's say her number is 333, 33333. Okay. And now what I can do is I can do phone book. And what's the way I can get back Kazi's phone number, right? So imagine you go to your phone, your iPhone or whatever you have, and you simply swipe up or down, right? You go to your, where's contacts? How does contacts work? I go to my contacts and I type in, let's say, my name, right? So how does it find it and how does it give me back the actual number? Well, today you're going to find out the secret behind how it works. Okay, so it takes in the key or my name, Rafik Kazi, and it spits back the value associated with it. It could be my email address, it could be my phone number, it could be whatever the heck I want it to be, right? So now let's go into phone book and we can say Kazi, right? That's, you put in the key and this whole thing liquefies and turns into the value. Okay, so that whole thing turns into one value. Okay, so let's print it out and let's see what we get. And I'll break it down how this expression works. So we got back 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Phone book is just this whole dictionary starting with the squigglies, right? So phone book is this thing right there. And I'm indexing that phone book by Kazi. Okay, so as you can see, I have this list here and I'm simply indexing it by QAZI. Okay. And once I index it, what happens here, right? Once I index it by Kazi, I just get back the value. So this whole thing liquidates into that, and then that result actually gets printed out on the screen. Okay, that's how the dictionary works. Now, let's say I wanted to make it a little bit more complicated to where each person had, you know, like their names, and each person had their own email address associated with them and whatever, right? So we could make it a little bit more interesting. For example, let's say that I wanted to add more values associated with Kazi. I don't want just his phone number, but kind of like how my phone does it, it also has Kazi's email addresses and it also has Kazi's home address and whatever else, right? So how would I do that? Well, what I need to do is I need to have one key that gives me back multiple values associated with it. Here I have a key Kazi, I have a key Bob, and I have a key Cat. So what I need to do to Kazi, for example, is make it give me back multiple values. Well, what's a pretty darn good thing to give back multiple things? I remember, it's a list. How about a list of things? So let's turn this from a bare string to a list that contains 1, the phone number, and then we can say 2, it contains 1 email address. So we can say kazi@kazi.com. Okay, fake email address. Let's close that down there. And okay, sweet. So now we have a list containing 2 strings inside of it. The at first index, it's a phone number, and then, or is a 0th index rather, and then at the first index we have the email address. I can do the same thing to the other ones, but let's just play around with it and see what we get. So I'm going to change this from phone book Kazi, and I'm going to say, okay, I know that once I run this line of code, what I will get back is actually this list. This whole thing is actually going to evaluate to the value of Kazi, right? So you put in the key, look at the formula at the top, right? You put in the key and you get back the value from the other side. So I'm going to run it and let's see what we get. So you can see that we get back the value. I know that this thing is going to turn into a list. Then I have to think about how can I access different things from the list. Let's say my question to you was, can you get me Kazi's phone number? You would say, okay, I'll get you Kazi's phone number. I know that it's inside of a dictionary where the key is Kazi, where there is a key Kazi. And if I access that key Kazi, right, if I access the key, the dict, and if I access the key Kazi, I get back a list of things containing his phone number and email, right? So you're like, now I know that I have a list of things. How can I access things inside of a list? I remember how you access things inside of a list is based on the index number, right? So for example, if I go up here, if I have to access the first element or the 0th element of a list, I would do this, and this gives me the first element of the list. Whereas for a dictionary, you would actually put in a name or something that's nice and easy to remember. In a list, you use numbers. So then you go, okay, well, I know that Kazi's email address is at position 1, right? This is index 0 and this is index 1. So if I ask you the question of get me Kazi's email address, you know that this whole expression evaluates to a list. Well, then you can just say 1, right? Just like this thing over here. And let's change that to 0th element of the list just to be very accurate. Let's hit that, and you can see that I get back Kazi's email address. Well, what if I wanted to get Kazi's phone number? I would just change this to a 0, and you can see that I got back that's the same thing. Now let's say I want to do the same thing for Bob, right? This is the phone number. This is bob@bob.com. And then we have, let's turn this into a list of things, and let's call it cat@cat.com. And we have this closing. Oh, I have to make sure that I close my quotes here, close the quotes there. Okay, great. So I have a phone book. Let's get the terminology right. Let's just practice with the terminology. It's good to say it over and over again. I don't care if I sound crazy, and you shouldn't care if you sound crazy, but understand the terminology because it's going to help you be able to research it better, understand it better, synthesize the information better, and be able to write better code ultimately because you will understand all of the data structures. Whereas if you just keep mumble and hand waving, you're going to get very confused later on. You might be able to get past some of this stuff, but then when we get into lists inside of dictionaries, inside lists of dictionaries, it's going to get very complicated. You're going to be like, oh man, I wish I learned the terminology when it was nice and easy. So let's just talk through it. I have a dictionary that contains how many keys? 3 keys. What's each key's name? Kazi, Bob, Cat. What do each of the keys contain? Each of the key contains a value, and that value is a list. Okay, good. Each key contains a value, which is a list. That's good. And how many elements does each list contain? Each list contains 2 elements, right? As we can see right here. So now if I wanted to get Cat's number, I could do cat, and I can say 0, and I get back 333, 3333, 333. So let's give it an example. Let's give it a run, and you can see on the right hand side, that's what I get back. Okay, so I will leave this here for you guys, and I will link you guys to the code so you guys can go and play around with this stuff as well. Okay, that's it for dictionaries, and we will get into its better use cases later on. For now, you're gonna watch Boolean Algebra Jiu-Jitsu after this video. Great job, guys. Take care. I will see you in the next video. Hey guys, what's up? This is Kazi. This is my third time making this video. The last two recordings got deleted and they were really long. I'm gonna try to make it short and sweet, right? It only lets me make them better, so that's what I'm actually excited for. Anyways, in this video, we're gonna talk about Boolean Algebra Jiu-Jitsu, okay? Before we get to that, I'm gonna just take a second to show you guys. Check it out. The official Clever Programmer Premium short sleeve t-shirt. Custom designed. Let me know what you guys think. And I'll put in the link for you guys below. So if you guys want to actually get it, you can order it. Some feedback would be great. If you think it sucks or if you think it's good, let me know. I would love to know that. Let's get on with what we are trying to cover for today, okay? So I want to talk about Boolean algebra, all right? So what is it and how does it work and why do we need to know it? It's one of the most important things in programming. That's it, period. In all of computer programming languages, anything that you use, even in electricity, it's super important. At the end of the day, everything turns to 0 or 1 or true or false, okay? So we have false or true. Notice how there's special statements in Python, which is why they highlight into the color orange. And then it doesn't give you an error. Python like understands what true and false is. For example, if you do true like this or false like this, it's going to give you back an error saying, I have no idea what you're talking about. So they're like pre-existing things that are built into Python. Now, why would we need to ever use this, right? Why would we need to use this? Well, let me show you guys something that foreshadows a little bit into maybe one of our next few videos, like conditionals and control flow, where I'm going to talk more about if statements, but let me just foreshadow that and show you guys so you guys can see from a bigger picture perspective how it works, and in turn that would make you want to learn what it is, and then we can get down into the nitty-gritty details. Cool? So for example, an if statement works like this. You have an if statement followed by some condition, which does not need to be in parentheses, but I'm just putting in parentheses, and that condition evaluates to a true or a false statement, okay? And based on that, right, based on this, then this. So it's like, if that, then this, okay? So if Johnny worked overtime and he worked more than 40 hours, then I want to pay him overtime, okay? So for example, the only time this block of code runs is if Johnny made more than 40 hours, which means it needs to evaluate to true. You need to have a true here, okay? So let's say if true, print hello, okay? And notice that this block of code runs because this statement is true, and then this block of code runs, right? This is the if condition. It's not very smart what I'm doing here. It's kind of stupid. I'm just hard coding true right in there, which is not what you're going to be doing most of the times, but I'm just doing this to like illustrate how it works in its bare bones skeleton, so to speak. And let me show you if false, and then see what happens. Print hi. And you can see that this part of the code did not run because it goes, oh, false. It's false, so I'm not going to run it. I'm not going to do this, right? If false, then, you know, don't pay him overtime or whatever, right? I could have anything else here. I just have print hello, but the implications of this are far more than printing stuff. It's doing actual stuff, right? Now, another reason why this is very important for you guys to learn is, imagine if you were hired and you were working in a company and you had to design a system for paying employees. Well, if you do your logic wrong, then you might be paying every employee overtime, which means that the company is paying way more money to its employees Like for example, you might write the logic wrong, and employee that works 3 hours might be getting paid overtime for all of those 3 hours. The company has to pay a lot more money, and then the company has to fire a lot of people because they're like, whoa, there's a lot of money going out of our pockets, right? On the other hand, you could have the case where no employee is getting paid overtime, even though they worked overtime, over 40 hours. So with great power, right, as being a programmer comes great responsibility. So that's why you want to learn this stuff really, really well, so you don't make these big mistakes, and you can help out companies, and you can help out clients or whoever, right? So we have this case, false print high. That's what happens. But now let's do something more interesting. So I'm going to introduce you guys to something called comparison operators, okay? So you guys might know the equal sign. It compares two things together. Not one equal sign that makes something something. Two equal signs check if one thing is equal to another thing, okay? So I have two equal signs. I have less than or less than. I have a greater than sign. I have a less than or equal to sign. I have a greater than or equal to sign. And I have a does not equal sign. Okay, these are your comparison operators. So what do I mean? 5 is equal to 5. It's going to give me back a true, right? 5 is 5. How about if I said 5 does not equal 5? What do you think it's going to give me? False, right? That doesn't make any sense. How about 5 is greater than 5? Does that make sense? No, it's not. 5 is less than 5? Nope. 5 is less than or equal to 5. It should give me back a true. 5 is greater than or equal to 5. And it also gives me back a true because it's not greater than, but it is certainly equal to 5. Okay? So that's how this works. And look, at the bottom, it breaks down into true, false, right? Now, let's say we wanted to pay Johnny more if he worked, going back to our original example, let's say we wanted to pay Johnny more if he worked extra hours, right? If he worked 40 hours or something. So how would we check that condition if he worked more than 40 hours? How would we check that? We have to make that condition. We have to check that condition. So these are all called conditions because at the end of the day, they evaluate to a true or a false, okay? So this is a condition and it evaluates to a false here. So let's make a variable called Johnny hours worked, and let's set that equal to 40. And now let's check it. Johnny hours worked is greater than 40. So I'm like asking my computer a question, and it'll say false. Okay, so I know I shouldn't pay him overtime then, right? Because I got back a false. What if I did, is he doing more hours than 30? Okay, good. So at least he's working, right? He's not just not doing anything. Okay, so he's worked more than 30 hours, but he has not worked greater than 40 hours. Okay, has he worked greater than or equal to 40 hours? It says true. Since I know he hasn't worked greater than 40 hours, then in this statement, greater than or equal to 40, I know that he's worked equal to 40. But let's just double check and say equal 40. Okay, cool. So we now know that Johnny has worked exactly 40 hours. So we can't pay him overtime in this case, but let's just try it out anyways. Let's do, if Johnny, let's turn it into like a conditional statement, which again, we're going to get more into later, is greater than 40, right? Then print pay him overtime. Oh, looks like we're not going to pay him overtime because he has worked exactly 40 hours. Now let's make Johnny's hours 41 hours. Let's say he's worked 41 hours, right? So overtime. Now let's run this and you can see that it says pay him overtime. So how could this translate for you? Oh, first of all, let's just break down exactly what this turns into, right? So we have this statement, if Johnny worked greater than 40 hours, how does this actually work? Well, what is the variable Johnny hours worked? We made it 41, right? 41 is greater than 40. Is that true? It certainly is. 41 is greater than 40, and we get true. And then we get into its most bare bone skeleton structure, which I showed you guys up at the top right here. And it's simple. It's simply just a true at the end of the day. And then this block of code runs, okay? And if the same way, the reason why this line of code, for example, like let's say I do this, right? If you work greater than 42 hours,
Why does this line of code not work? Well, again, Johnny hours worked is 41. Is 41 more than 42? Of course not. So this turns to false. And when this turns to false, we get back, we actually get back nothing because this line of code does not run. Okay, that's the bare bone, like that's the main reason why we use Boolean operators. There are lots of other reasons that you'll see as well. In the next video, we're gonna get down more into how Boolean logic works. So for now, I showed you guys comparison operators. In the next video, we're gonna talk about Boolean logical operators. Okay, so for example, we're going to talk about and we're going to talk about or, and we're going to talk about not. All right, and how all of those things work in sync with each other. That's it for this video. I'll see you guys in the next video.
Guys, what's up? This is Kazi from cleverprogrammer.com. In this video, we are going to talk about Boolean logical operators. So in the last video, we covered the basic jujitsu of Boolean algebra, kind of like what is the basic, most fundamental ideas behind Boolean algebra. And we saw that everything that we talked about converts to either true or false, right? So here we have all these things converting to true or false. That's effectively what ends up happening at the end. So now let's go and talk about the operators that I was mentioning. Okay, so before I start giving you their rules and how they are defined in the world of electricity or logic gates or programming for that matter, I want to just give you guys an intuitive sense of how it works, because that's way more important than memorizing these, truth tables for a lot of these cases. So let me try to give you guys an intuition. So let's start off with and. Okay, we're going to start off with this logical operator. As you can see, it's a special word in Python, which is why it highlights to orange. If you write and with two D's, it does not highlight to orange. And let's talk about what it does. So let's say I did, 5 and 5. It'll give me back a 5, and here it's not really making sense. Let's try true and true, and let's see what it returns. It returned true. Now let's try something like true and false. Let's see what that returns. That returns false. So now let me try to give you guys an intuition of how it works for and. Let's say there are two things. I ask you, do you like poison and do you like pizza? Right? If I asked you that question and you could only answer with yes or no, what would you say? Hopefully you would say false or no, right? And then and if I asked you to elaborate, then you might say, I might like pizza, but I really don't like poison, right? So the idea behind you not liking poison, but you liking pizza, that whole thing, when you combine it with an and, that whole thing becomes false. Because there's one of those things that you don't like, so you can't say yes to the whole expression that I gave you, right? For and, both of the things have to be true for you to say yes to it. Like if I asked you, do you like pizza and ice cream? You'll say yeah, right? But if I tell you like jumping off of the cliff, or do you like doing your math homework a lot, and do you like writing essays? In that case, probably both of the things you might not like doing, your math homework and writing essays, and you might say, no, I like doing neither of them. Or for sure, you would say false, right? So I can say something like math homework, let's set it to false, meaning like you don't like it. And let's say long essays is equal to false. And now let's combine the two. Let's say math homework and long essays. You get back false, right? Math homework is really false and long essays are false. So false and false gives you a false. Now let's try
pizza, and let's say we like it. For my friend Daniel, he loves pizza. So if you're watching this video, that's who I was thinking of when I came up with this example. Let's do ice cream, and let's set that to true, meaning we like both of them. And let's do pizza and ice cream, right? And you get back true. So even thinking about it logically, whenever you combine something with an and, both of those things are now combined. So when you're answering for both of them, even in real life. Both of those things have to be true. Johnny, go throw out your garbage, and then you get to play, right? So in that case, both of those things happen to be true. If you throw out the garbage, then you kind of get to play. It's a little bit of a contrived example. There's more of a if-then statement rather than an and. Okay, how about this? Even better. Johnny, throw out your garbage and do your homework, and then you get to play. Okay? In that case, the only way Johnny will get to play his game is if he has thrown out the garbage and done his homework. Much better. Now I can sleep better. All right. That's the breakdown for and. So now let me just give you some problems and throw it at your face. Okay? False and false. Quickly, what do you think it's going to be? You should have said false. False and true. Remember, one of them is false, both of them end up being false, because we can imagine that this is poison and then this is pizza, and you can't say true to both of them because there's one of them that you don't like. For it to be true, both of them have to be true. What if I gave you true and false? What if I gave you true and true? What do you think that would be? Okay, hopefully you're starting to get a little bit of sense of this. Why this will be important later on is once we get to the conditionals and control flow section, which we should be getting to in the next video. In there, we're going to be talking about how you can combine an if statement, use an and to check two conditions, and then the block of code runs. So if Johnny homework and pizza, or and throw out garbage, then this code here runs. Okay? Obviously, I'm going to get syntax errors right now because I haven't defined Johnny homework, I haven't defined throw out garbage, and you can't write stuff separated by spaces. And I don't know who writes capital variables. Only if it's constants, but we'll get to that later. All right. So now let's go to the or side of things. What if we combine two things with an or? If I asked you, do you like pizza? Okay, so for sanity check, assume you like pizza, even if you don't. Okay, so just to play along, just imagine you like pizza. So if I asked you, do you like pizza or doing homework? If you had to answer that with a true or false, what would you say? Do you like pizza or doing math homework? If you could only answer with a true or false or yes or no, you should say yes. Or you should say true. Because there's one of those things that you like. And I asked you or. They're not connected with each other, right? A or B. So let me show you guys this in code. If I do false or true, check out what you get back. You get back a true statement, right? If I do true or false, I get back a true statement. And if I replace this with something that we understand better, let's say we don't like poison. Poison is equal to false. And let's say we do like pizza, and we already have pizza as true, but I'm just going to do that again. And now let's write this statement over here using pizza and poison. Pizza or poison. I misspelled poison, but in one of my older videos I had it there, so don't worry about why it figured out what poison was. But yeah, let's just use this poison variable that we wrote here. So you can see that we get back a statement that's true because one of the things is true, and in this case that's pizza. So for an or statement to be true, only one of the things have to be true, right? If I asked you, do you like ice cream and or pizza, you would say true if you could only answer that with one thing. Just like if, again, we take Johnny or our son Bob and we go, Bob, either if you do your homework or you throw out the garbage, then you get to play. So he just goes, oh, sweet, I'm just going to throw out the garbage. So this way, he doesn't have to worry about doing homework. He decides to only do one of the tasks and then he can play the game. But what if he went and tried to be extra nice and threw out the garbage and then went and did his homework? Would us being his dad or mom still allow him to play? Of course. He did both of the things. Great. That's extra bonus. But for him to qualify as a player or like go play his games, he really needs to do only one thing. That's what the or does in our real life. And so that's what it does in programming as well. So now let me just throw some examples at your face and you try to figure it out. True or false? What do you think I'm going to get? Quickly. I'm going to get back a true. Only one of them has to be true. What if I did true or true? What am I going to get back? True, obviously. What if I do true or sorry, let's do false or false. Two false statements. Do you like poison or homework? You're going to say no, none of them. There you go. So that's a little bit of a breakdown of or. And if I wanted to break down not for you, not is very simple. Not is just something that doesn't happen. Okay? So it's just a negation of something. So if I said not true, what do you think I'd get back? I'd get back false. If I did not false, what would I get back? True. It's just a negation. So if I do something like not true or false, what do you think I'm going to get back? What is this expression going to evaluate to? True or false? Remember, for something to be true in the or, combined with the or Boolean logical operator, only one of the statements has to be true. So here we do have a true. So true or false evaluates to a true. And then, right, this pretty much becomes true. And then calling not untrue gives us false. So now let's just run it. Okay, and as you can see, we get back false. So what I'm going to do for you guys on cleverprogrammer.com is if you guys go to submit your exercises here, what I'm going to do is I'll have, if you go to watch the video course on my website, I will have exercises here for you where you can kind of drill and kill how true and false and this stuff, Boolean operators work. That's going to be very, very useful for you guys. So then when you're writing your if-then statements, you'll understand what you're doing. Okay, but this is kind of, we just need a basic understanding of it. Some places go really crazy in depth into it, like creating things like not true or false or true, just combining it and making it into like these can be good exercises for you to figure out, but realistically when you're writing code, you're not going to be doing stuff like this. So if you can figure this out in your head, great. But you're not writing code like this most of the time. So I wouldn't want to worry about it too much. But if you want to go ahead and give yourself some crazy exercises like this to do, or come to my website where I'll have some exercises for you guys to do, that would be great. And before I conclude this video, let's go back to here. I have put together a truth table for you guys, or rather it's on wikimedia.org. So I didn't put this together, but I have an image. I'll link you guys the image and you can see how the truth tables work. So in the A column, we have some statement. Imagine it being pizza, right? We have that statement, and B, say some other statement. So we don't really know what these statements are for now, but you can imagine them to be whatever you want. So let's say we have some statement A and some statement B. If A is false and B is false, then A and B, you get back false, right? Remember, and so if you have, again, A being poison and B being homework, poison and homework, you get back false. You like neither of them. And if we have A or B, since both of them are false, it's still false. And not A is just the opposite of that. You get back true. And same thing over here. We have false and true. False and true gives you back a false. False and true, you only need one thing to be true in or statements. You get back a true. And then not A, which is saying, opposite of A. Since A was false, you get back a true. Okay, so one thing I want you to notice about AND operator and OR operator is if you look down the column of the AND operator, you'll only see one true case. And the only reason why it's true is because both of the statements are true. Okay, that's the key thing to remember. Both of the things are true. And if you go and look in the OR column, you'll see the OR being false only in one case. And the only case is false is when both of the things are false, okay? So notice the key distinction between the two. Okay, that's kind of all you have to know for Boolean stuff. And I'm not going to go into the next video with really long nested Boolean statements. It's kind of useless. We don't really think that way anyways. And we're going to get into conditionals and control flow. So I will see you guys there. Hey guys, what is going on? My brain is about to blow up. I've been reading this book called The Little Schemer, and it's about this programming language called Scheme. And in this programming language, everything is done really difficult in a very difficult way. And I spent 8 hours studying it, so my brain is like fried. But I'm excited to take a break from studying it and get on with teaching something about computer programming in Python. So we covered in our last video Booleans, and we talked more specifically, we covered the Boolean logical operators. We talked about and we talked about or, and we talked about not. So another thing I wanted to mention to you guys, I had it open here so I don't forget. If you guys are on my website, you can write code directly underneath while you're watching the video. So you can write something like print 5 or whatever and hit this and it'll run it and actually give you the results. So if you're having problems running your code or you just want somewhere easy to run it, well, you can go here and watch the videos and run it at the same time. Back to where we were. Okay. So as you can see, we covered a lot of this stuff, right? With and, or, and not. So now let's do some examples where we combine our conditional control flow with our Boolean logic, okay? So this is what's gonna tie it all together. This is what's gonna allow you to make powerful games and do powerful things right now, okay? Not in 100 more videos, not reading another book. You can start to build games and functional programs doing what I'm about to show you, okay? So let's get to it. So I showed you, okay, you have Boolean operators, like you do true and false, and you get some result. Now, I also showed you how you can have some examples like Johnny homework and then this code runs here, okay? I showed you that at the top, so let me just bring that down. Whoops. The whole example. This is not real code. This is just, this is going to give you wrong answers for now. So now let's try to do those things where if you had an employee that was getting paid over 40 hours and you wanted to give him overtime pay, again, let's tap it all in here and let's see how that would work. So if I did Bob hours worked and I said, okay, he worked, let's say 40 hours. And if I said, if Bob hours greater than 39, then print, he worked overtime. For some reason, we have less than 40 hours as overtime, but whatever, never mind that. He worked overtime. So let's see if that prints out. If it does print out, then that means he worked overtime. And as you can see, Bob hours worked were 40. 40 is greater than 39, so that part evaluated to true, and then you got back this statement. Now, what if we wanted to make it a little bit more interesting?
let's go back to the example of the kid where he throws the garbage and he does his homework, right? So for example, let's say Johnny homework is equal to true, meaning he completed his homework assignment. Now let's say Johnny throw out garbage, and let's make that also true. So he's done both of the things. Now let's see if he gets to play a video game. Okay, let's see if he gets to play his Xbox 360. So if Johnny homework, right? Dad says if Johnny does his homework and Johnny throws out the garbage, then Johnny can play Xbox 360. Right? So if that statement prints out, he can play Xbox 360. And I don't know why I'm writing Xbox 360. I feel like I'm living in 2005. Xbox One has been out, and I'm pretty sure in the next few years they're going to bring out the new one. So let's change this to Xbox One. And let's hit enter. So it printed it out. Johnny can play Xbox One. How did this work? Johnny homework evaluated to a true statement. Johnny throw out garbage evaluated to a true statement. The only time you get back a true when you combine something with an and is when both of the statements are true. So true, true, and we got back that, right? Now, just for some little exercises here and there, what if I did something like not Johnny homework, Johnny homework, or Johnny throw out garbage, right? What do you think I would get here as a result? Let's think about it. So if you guessed it correctly, good, pause the video, or let's try to figure out together. So not throw out garbage, not true, right? Throw out garbage, true, not true gives you false. And this part is true. So you essentially get true or true, and then not true or true gives you back true, because for an or condition to evaluate to true, only one of the conditions have to be true. And then calling not on a true statement gives you back a false, and hence we get a false, okay? Again, I'm not going to focus so much on these contrived, forced Boolean examples because your thing is never going to get like that. And but it's just good to know how it works, right? It works through the inner parentheses, inside of the parentheses first, and then it goes outside of the parentheses and starts to evaluate things, okay? So you can see we were able to put things together. Now, imagine if you were making a game of rock, paper, scissors, right? Let's rock, paper, scissors, right? I can say if human picked, let's say rock, and computer picked scissors. Now I can say if, let's see, what can I say? I can say something like if human equal rock and computer picked scissors, then who wins, right? Who gets the point here? So I am going to say then human score is equal to 1. Okay? So human picked rock, computer picked scissors, right? In rock, paper, scissors, just in case you didn't know, rock beats scissors. And now let's check the human score. And you can see that I got back a 1. Okay? So that's why if conditions are so important. We can also start to tack them on. Okay? So let's say that, let's say if human picked rock and computer picked scissors, if this was not the case, what if there was some other case? Let's say computer picked something else. So let's say computer is bananas, right? So if I write this line of code, how can I check for other things? So I can say, I can say else if, I got to get outside of the if statement. I can say else if computer, human picked rock and computer picked bananas, then you can say, I don't know, computer score is equal to 0, and human score is equal to 0, because bananas is not really a valid thing. So you get back both got 0, and then it says something like print you can't pick you can't pick anything other than rock, paper, or scissors, right? Something like that. And let's hit it. And so you can see that first it checked this if condition. It checked if human is equal to rock. Well, human was equal to rock. The only way this statement will run if both of the statements are true. That's what the AND forces you to do. If we had an OR here, what it would do is it says, if human is rock and computer is scissors, okay? So in our case, it would go, is human equal to rock? It would say true. And it would go, or computer equals scissors. It would evaluate that to false, because bananas right there does not equal scissors. So it would go true or false. It would evaluate that as true, because true or false is true. And it would go, oh, okay, human score is equal to 1. Okay? But we don't want that. We want both of the things to be true. If human picks rock and the computer picks scissors at the same time, that's when the human wins. But in this case, computer picked bananas, and we said if you picked bananas as, if that happened where human picked rock and computer picked bananas, we can say that, you can't pick that. You got to try again. Now, why a OR statement is useful is imagine if, do you care who picks bananas? Do you care if computer picks bananas or human picks bananas? Should you stop the game if either of those people pick bananas? Yeah, you should, right? You should stop the game and start it again, because banana should not be one of the options. So you don't care who picks something that's the wrong one. You just care that wrong one is picked. That's why you would use a OR. You would say if human equal bananas, or computer equal bananas, then print blah 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 blah, right? In this case it won't make sense, but then whatever, right? We print out this line of code. Else if, notice the else if, it's used to connect these. If you wanted to actually write it as, I can show you that later, but if you essentially want to write it, what you have to do, and you're writing it where these 3 dots aren't there, right? You have 3 dots that are showing up here. So let me bring down this if then whatever statement down for you. So if you ever have the case where these 3 dots are these three greater than signs are there, then you have to put the else if not at the same indentation level as an if. But if you're doing it and you're writing this code as a script, then that's how it would be. The if and else if are at the same indentation level. Okay, they're not at a different indentation level. That's very important. Otherwise, the code is not going to run. Okay, and else if helps you join an if with an else if statement. And another one that you might need is else. And else does not care for a condition. Okay, you see your if statement cares for a condition, and then it runs the code. Your else if statement cares for a condition, and if that condition is satisfied, it runs the code. Else does not take in condition. If none of these guys match, then else runs by default. Okay, so if condition, all right, if this condition evaluates to true, then this block of code runs. Okay, good. Again, or we don't care who did the thing. We don't care who committed the crime. If any one of them did, we just break it. Realistically, when you have this case where human is bananas, or you're not gonna put every single option ever that could be wrong, right? So you can't check for bananas or spaghetti or pizza. What you can check for is human did not pick if one of them did not pick, let's say, rock, papers, or scissors, then it should be wrong, right? So let's see if we can write that. If computer does not equal, right, we can say rock, or computer does not equal scissors, or computer does not equal paper, then print wrong choice, pick again. Okay, so now let's try it. Now let's say computer is equal to rock, and let's run that piece of code, and it says wrong choice, pick again. Okay, so you can see how using the OR statement here ended up giving me the wrong result. What I want to make sure is that the computer is equal to any one of these, right? So let's try it like this. Let's say computer does not equal rock, and computer does not equal scissors, right? And computer does not equal paper. Right? Let's let me just go a little bit here, make it bigger. Then print wrong choice, pick again. Okay? So the only way this code will run is if all of these things are true, meaning computer is not rock, computer is not scissors, and computer is not paper, right? So if I made computer is equal to banana, and I went up here and I ran this code, you can see that it checked, hey, is computer rock, is computer scissors, is computer paper? If it's not any of these, then print wrong choice, okay? So you can see how powerful these combinators are. Is that what I would call them? Like your logical operator, Boolean operators, right? Like and or. You really, really need them to be able to do this stuff, okay? To be able to do really powerful things. Okay, I'm gonna cut this video off here. Hopefully you have a much better understanding of how this stuff works. Okay, in the next video, we will cover for loops, and I will see you there. Hey guys, what's up? In this video, I want to talk about for loops and how they work. Okay, so we're gonna get into loops. You saw that we did a lot earlier when we were using the turtle module, so hopefully they're a little intuitive to you by now. But now let's use them for more, I guess, realistic purposes, right? Things to do with numbers and manipulation of data. So not only can you use it for visual graphics, but you can use it for anything now. That's what I'm going to teach you. So if you're making your own game, you'll be able to use it after learning these things. Or if you were creating your own script, maybe you're at a job, whatever is the case, you're going to become more familiar with loops, and it's going to help you do a lot of powerful things, okay? So let's get started how loops work. Essentially, it's a way of doing something multiple times. Whenever you think, I need this done a lot of times, what can I do? For example, if somebody told you print out numbers from 1 to 2, you'll be like, okay, I'll just write print 1 and print 2. Good. But now what if that same person told you print numbers from 1 through 10? You'll say, okay, I'll just write print 1, print 2, print 3, print 4, print 5, all the way up to print 10. Whew, a lot of typing, but hey, it wasn't so bad. Now let's say I tell you to print up to 1,000. Could you type that? Of course you can. Would it take you maybe 2 hours, 3 hours? Maybe. You'll copy paste, you'll do tricks. It'll be harder. Now if I tell you to type in 1,000,000, it's going to get much, much, much harder. Okay, so for loop helps us overcome the burden of doing repetitive tasks. So let's try something. Okay, let's say I want to do something 5 times. That's how I would say it. Okay, I want you to look at it less from Python syntax specific perspective of I want to zoom in microscopically, and what is I? It's hurting my eyes, and what is range, and what does it do? And I'm getting a headache over here. And where do I put a colon? Where I want you to read this as do something 5 times. Okay, That's how I want you to read it. Do something 5 times. That's what this is saying. And here I'm going to say print hello. So if I told you do print hello 5 times, that's how you would think of it. You would go, okay, print hello 5 times. You would say do something 5 times. And that something is print hello. Okay, I want you to get an intuitive sense of this so then you can reproduce these and do them on your own, away from the screen, okay? So for example, now let's run this code and let's see what it does. And you can see it printed out hello multiple times. Now you might be asking, what is I? If you don't already know, you can call it whatever you want. You can call it banana. The code will still run. What we need to do is break this down one line at a time if we need to look at it more introspectively and see what's going on. So what is range of 5? Well, let's check it out. Let's see what range of 5 is. So I'm going to print this out. Range of 5 is really a list of numbers from 0 through 4, okay? So to use loops, you need to know what a list is. Since we've covered what a list is, there you go. So range of 5 really evaluates to this. Okay, when you write, the reason why I should write list here is because Python hides it, it secretly writes it, and you can't tell what it is. And especially since you're starting out, this is going to confuse you when it says that, okay? When you get more advanced, you'll know why it says this. But for now, I'm going to not hide it, unhide it, and take out the actual form of what it looks like. And I know that if I call list, it'll show you like the actual type of what it's doing under the hood. So essentially, whenever you see a range of 5, you should think, oh, that's just this. It's a list containing 5 elements starting from 0 all the way up to 4. Okay, so now we can start to break all of this stuff down. We can go, okay, if range of 5 is really this, so range of 5 is actually that, 0, 1, 2, 3, 4. The first time, right, let me write this code here. Let me change this hello and let me change it with an I. Okay, and let's do that. And you see 0, 1, 2, 3, 4. What happened there? So let's see. The first time we ran the code, I is 0, so it prints out 0. The second time we ran the code, I went and became the second element of the list, so I became 1. Then where I was here, it became 1, it printed out the 1. Then I became 2, it put 2 here, printed out 2. Then it became 3, 3, 4, and printed out 4. And there you go, you see all of that on the right hand side. 0 got printed, then 1 got printed, then 2. That's why it's all separated by a line. Okay, so that's really what that I there does. Could we call this number? Yes, we can, and that's actually a better variable name. So my suggestion to you, especially if you're starting out with programming, never ever use 1-letter variables. Never. Okay? So even if you think you can use an I here or an X or Y, don't do it. Take your time and pick better variable names. So I'm going to change this with number because number is that variable. This variable we created on the fly. And I'm going to say from 0 through 4. Now let me tell you something about the range function in Python. The range function takes start and stop. Okay, but it's kind of like this if you have to think about it mathematically. It includes this point, which is why I put this here, and it goes up to but does not include the stop. Okay, so the range function takes in 2 arguments, start and stop. So if I gave it 1, or let's say I gave it 0, and let's say I gave it 10, you get back, let's just do 2 because I'm lazy. You get back 0, 1, and 2. Well, what if I wanted to print up to from 20 to 40, right? What if I wanted to do that? Well, I can certainly write a list from 20 to 40, right? I can go 20, 21, 22, 23, 24, all the way up to 40, but that would take a long time. Let's use range to generate that on the fly. Let's start with 20 and go up to 41, but not including 41. It excludes the 41. So this actually translates to a list starting from 20 going up to 40. And if we print it out, you can see it goes from 20 all the way up to 40. So loops are great. Now,
In the next video, I want to talk about while loops. But before I get to that, I want to tell you something. So up until now, we've done a lot of Python syntax stuff, learned the basics of Python and how it works, programming specific syntax, where do you put the colon, where do you do this. Now, after this point, especially after the while loops, we're going to get into exercises, and we're going to kind of drill and kill exercises. I'm going to make this the best Python course there is for learning Python, hands down. What's lacking from a lot of the online video courses are exercises, and I'm going to give you guys so many exercises, it's going to hurt your brain, but in a good way, whereas it makes you smarter and you get better. Because without doing exercises, you will not get better. You can look at me write code all day long, you're not going to get better because of that. You need to do it on your own, no matter how simple it is. And while Codecademy and all those things are great, they handhold you quite a bit, which means that you're not really learning a lot of those things, okay? So we're gonna take a break from a lot of these tutorials and do exercises, really get these ideas down, okay? What do I mean by an exercise? Let's do an exercise right here, right now, okay, live. I'm gonna leave this here for you guys because I wanna leave this link into the YouTube description so you can actually go look at these notes, okay? So I'm gonna save this and I'm gonna leave this as notes. Print numbers from 20 through 40, including 40, right? Or rather, I can say through 241, and I can say excluding 41. That's probably a better way for me to write it because that's how Python thinks of it. Okay, now let's do an exercise. Let's say that we take numbers from a list, sum them up, and return them. What do I mean? If I give you a list containing 1, 2, 3, you should give me back 6 because 1 plus 2 plus 3 is 6. So if I gave you this list, you should give me back a 6. But now let's also start adding together everything we've learned so far. Let's create a function, okay, that takes in something and then does it. So we're gonna build up to that, okay? So first, let's just write something using a for loop that sums up all the numbers in the list and then returns them back to us, okay? Or prints them out back to us. So let's do this. Let's say count is equal to 0. So we're gonna use some variable to keep track of every number. So essentially then we can say that if when we go through the loop, we can say, okay, I want you to add 1 to count. Then when I want to go through the loop again, I want to say add 2 to count. Then when I go through the loop again, I want to say add 3 to count. Okay? And so in the start, you'll have count being 1. Then you'll have it being 1 plus 2, so 3. And then you'll have it being 2 plus 3, so 6. So you should get, back 6. So let's try it. So I will say for number in range, let's say range. What will I say to range to create a list from 0 to 3 or 1 to 3 basically? I would say 1 to 4. Okay, this creates a list of 1, 2, and 3. Okay, so I'm gonna say range 1 through 4. Okay, now let's do how can we increment count. Okay, I know that number is going to be 1 the first time, then 2, then 3. That's not a problem. So number is good, what we're getting with number. But how can I increment it to count every single time? Here's what I will do. I'll say count is equal to count plus number. Okay, what does this mean? Here's what this means. This says I want the new count to be, so the new count to be here. New count is equal to old count plus number, okay? So this is saying my new variable count is going to be what my old variable count was plus number, okay? So the first time we go through the loop, the number is going to be 1. Old count is going to be 0, okay? And so it's gonna say now count is 1, okay? Then when we go through the loop the second time, number is going to be 2. Oh, by the way, this count is gonna turn to 1, right? Because we redefined what count is. Then what's gonna happen is that number is going to be 2.
So essentially, you're going to get back count plus number, which is going to evaluate to count plus 2. And number is 2, and count was 1. So this is going to evaluate to 3. Store count as 3. Then you're going to get back count plus number here again, right? And then you're going to get, so the number is now this time going to be 3. And so you get back count, which is 3 plus 3. This evaluates to a 6, and our loop ends. Okay, so let's just undo this damage that we've done, and let's check it out. Let's print count. So we run through this entire loop, right? And once we're done running through this entire loop, we print out count. It should be in this case 6. So let's check it. Okay, and you can see that count does indeed give us back a 6. Well, that's great that we wrote a for loop that runs for the numbers 1, 2, and 3. What if we want to write this for loop and we want it to run, right? We want it to run and sum up lists for any list given to it, any size list. It could be a size 1 list, size 30 list, size a bajillion list, whatever. Okay, so let's see how we do it, okay? Because practice is key, right? How do you go from conscious competence to unconscious competence? That's how Jordan Belfort says it, right? The guy in Wolf of Wall Street, the movie who Wolf of Wall Street was the person who Wolf of Wall Street was based on. He defines two concepts: conscious competence and unconscious competence. What is conscious competence? That's you thinking about something and then being good at it. What's unconscious competence? You get so damn good at what you do that you don't even have to think about it and you do it. Okay? So how do we go from conscious competence, you looking at your notes, you really thinking about it and how does a function work, to like you just writing code? Is practice. Okay? There's no substitution for that. The only thing that you can do is hard work, okay? There's no getting around it. There's no, you can't watch somebody else's videos or my videos and just sit there and try to synthesize the information, be like, why am I not getting it? You can't just take notes all day from your professor. You have to try to do this stuff on your own. End of rant. Let's continue. So let's write this function that can take in any sized list and sum it up. Okay. So I'm going to say define function. Okay, so let's just write a little note at the top so we know what we're doing. Write a function that sums all elements of a list and returns them. Okay, that's what this is doing. That's what returns them. Let's just put a little thing here like this. All right. So let's write this function. I'm going to say define. That's the first step to defining a function. And I'm going to say sum list. Okay, so the function is called sum list. It takes in one argument. Let's make that argument be whatever, my list. Okay, you can call it whatever you want. You can call it A, B, C, X, Z. But remember my rule: try not to name things as one letter variable. Try to make it more descriptive. So I'm assuming I'm going to get a my list or a list as input. So I'm going to call it my list. So I'm going to hit enter now. What's the next part? Okay. Let's think about it. So the next part I want to put here is I want to have a counter variable, right? That's what we had when we were writing this for loop. And I want to say for number in, well, what's the list we're working with? Here, the list we were working with was 1 through 4, right? Kind of like this list. So imagine if we had that list as my list. Well, we know it's called my list. Whatever list we get is called my list. And so just so you guys know what we're kind of doing is eventually what we want to be able to do is say sum list and pass it the list 1, 2, 3. And this should give us back a 6, okay? So we want to say assert that sum list is this is equal to 6. Okay, so this is a nice little test for you guys which asserts things. For example, if I write an assertion that's false, it's going to give me back false. So if I said 5 is equal to 6, my code is going to yell at me. Hold on, I'm obviously having an error here because I'm writing funky business. But you can see I get an assertion error. It goes, hey, 5 is not equal to 6. But if I go 6 is equal to 6, you can see that assertion gives me a nice little 3 here, right? Which is, or sorry, does it give me 3 there? No, I'm sorry. Yeah, what? So assertion basically just doesn't give you an error, okay? When assertion works, it just doesn't give you an error, okay? So assertion doesn't give me back anything. It just gives me back no error when it works, and it gives me a big, red, angry, scary looking error when it's wrong. So I want to have this assertion here, and why this assertion will be helpful to me is it's going to test my code, okay? Let's have another assertion. And let's say 4, and this should give me back 10. So I'm also teaching you guys how to test your code. So once I write this function, you should be able to call the function by saying some list, passing it any list. In this case, this list 1, 2, 3, and it should give you back a 6, and it should give you back a 10. When you run this code, if it doesn't give you an error, that means it's passed all of these test cases. If it fails, it means it failed one of these test cases, and your code is wrong. All right, let's keep going. So I want to say for number in my list, right? That's the list I get. So remember, this list is going to be, if we pass this test case, right? If we give it this test case, then list is going to be 1, 2, 3, really, right? So let's just say my list. And what I want to do is, what do I want to do now? I want to go count is equal to count plus 1, okay? So even though we're doing this exercise right now, I'm going to have you guys do it again in the exercises portion, just so you can do it from scratch. For now, just watch along and get the concepts and how it works. Okay, so I increment count by, what should I increment count by? I don't want to increment it by 1. That would be wrong. I want to increment it by the actual number, right? So I want to say number here. Oh, I'm sorry, I wrote this wrong. I'm silly. I meant to increment it by number up there. Hopefully that didn't throw you off too much. Okay, so, but for you guys, when you guys look at the notes, it's going to be fixed, okay? I changed it to number. Sorry about that. All right. So whatever count was plus the number from the list. Okay, great. And now at the end, we have to say return count. Okay, just format it a little bit nicer. Let's remove some of these extra spaces and let's save it again. And now I'm going to run it. And if I don't get back an assertion error, which I didn't, that means it runs perfectly. Imagine if, okay, so if I said 1 plus 2 plus 3 should not give you a 6, let's say I said it should give me a 7, you'll see that it gives me an assertion error. It says, hey, calling some list on 1, 2, 3 does not give me a 7. So it should give you back a 6, okay? That's good. And just for sanity check, let's run it and print something. Let's say 1, 2. What should that give us? That should give us a 4, right? Or sorry, 3. 1 plus 2. Hey guys, how's it going? In the last video, we talked about for loops. In this video, I want to cover while loops. While loops are not used a ton in, especially in Python, but they're very important, and let's talk about them, because once you start to understand the concepts of while loop, then for loops essentially let you write it in a shortcut. But one thing that's nice about while loops, just to give you guys a little intuition of when to use while loops and for loops, generally you want to use while loops for things that you don't know about, when they're going to end, how long they can run for. And you want to use for loops for things that you know how long it's going to take. For example, if you want me to do push-ups and you don't know how long I'm going to get tired, you want to say something like, while not tired, keep doing push-ups. Okay? And then that way, while loop just keeps running till the person is tired, and then once the person is tired, it stops. For loops, you need to specify a range. So you would say, do 20 push-ups and then you can stop. So you would use a for loop for that, okay? While loops, you don't know something. For loops are better if you know something, okay? But I'm gonna right now show you a while loop that mimics a for loop, okay? So I want something to happen 100 times and then I want it to stop or something, okay? So let's just start with a simple example that counts. So let's say I want to do, okay, so let's start off with this. I want to say my count is 0. I start off with something that is at 0, and then it keeps printing something up by 1. So I'll say, how long do I want to run for? Okay, let me add at the top here in the while loop notes for you guys. Again, I'm using REPL.it. So then when I'm done making these videos, I can actually post a link so you guys can actually go through the notes yourself. So I'll put all these notes, I'll aggregate these notes and put it in the links below, and then you guys can just use them, okay? So while, and then some condition, and then if that condition is true, then body, right? Or then this. And then it keeps looping. Okay, it keeps looping back and forth. But once it's out of it, when the condition is false, then it ends. So it's like an if statement, but it keeps happening over and over again. So if you want an if statement to keep asking some question, that's how you should think of a loop. All right, so I'm gonna say, and remember, just so you know, condition example would be like 5 is less than 6. This evaluates to true or false. Okay, so this evaluates to true, right? 5 is less than 6. Another example would be 6 is greater than 5. Or let's make it so it's like this. This evaluates to false. So conditions are everything that at the end of the day evaluates to true or false. So if you took this condition and put it in here, right? This while loop will like run forever because it'll always say 5 is less than 6. All right, now let's keep going. While count is less than, how many times would we want to run? Let's say we want to run 100 times. Then I want to print what the count is. And what else do I want to do? If this statement says 0 is less than 100, it'll come down here and it'll print out, right? So for example, in the start, I made count to be 0. So if I do this and put 0 for count and 0 for count here, it's gonna print that out to the screen. And then what's gonna happen? Once it's done printing it out to the screen, we are gonna go back to this loop, and it's gonna put condition here again, right? Or yeah, sorry, count is gonna put count here, and we're gonna have count here. It's gonna check this statement again, and again we're gonna have 0 for count. It's gonna ask the question, is 0 less than 100? It's gonna evaluate to true. Then it's gonna execute this part of the code which says print 0 because count is 0, and then it's gonna print out 0 again. Then it's gonna go back to the condition. Is going to check if count is less than 100. Since count is 0 again, it's going to go back here. It's going to say print 0. Okay, now I'm going to run it and watch what happens. I'm going to stop it, and I think I might have crashed my computer. Hey there. So my computer just kind of crashed pretty bad, but hopefully that gives you a little sense of what happens. I should have ran this in my terminal. But it took it like 10 minutes to come back, and I had to rewrite the notes and everything. So let's go back. So this is a problem called infinite loops, where you write something where it doesn't match the condition. Like this thing, if it doesn't ever turn false, your loop is wrong. Okay? If that thing doesn't turn false, your loop is wrong. All right? Because that means that your loop is going to run forever, unless you put in this thing called break. But I don't want you to do that. Generally, that implies poor logic. So let's just keep going through this, all right? So we want this to turn false at some point, and we don't want to keep printing at 0 every time, right? So what should we do? If we leave this at 0, it's this, right? If I leave this at 0, this whole thing is going to evaluate to false. If this is... And I'm sorry. This is going to evaluate to true every time, okay? It's going to evaluate to true every single time because 0 is less than 100. Now, it's going to keep saying true, and the loop is going to keep running. If I change this to 5, this thing is going to evaluate still to true. If I change this to 90, this whole thing is still going to evaluate to true. What happens if I change it to 99? It still evaluates to true. Now, what happens if I change it to 100? This part of the code evaluates to a false, and we are done with the body of the we're done with the loop, and therefore we don't execute the body of the while loop. Okay, if I needed to add something else in my notes for the while loops, is this: go back to while loop, right? I would, if this condition is true, then do this, and then go back to the top of while loop. Okay, so we want this thing to turn false at some point. Here's how we're gonna do it. Okay, I'm going to say count is equal to count plus 1. So I'm just going to add 1 to count every single time. How you read this is that what count, new count, is what count previously was plus 1. So the first time we go through the loop, count is 0. It prints out 0 out to the screen. Then it prints out, then what it does is it says count is equal to count plus 1. So it says count is 0 plus 1. So the new count is now 1. Okay, then it goes here and it goes, okay, is 1 less than 100? Yes, it is. So it prints out 1. Then it goes here, and this really says count is equal to count plus 1. So it says 1 plus 1 is 2. Then it makes this guy 2, right? Then it goes, while 2 is less than 100, print out 2. And what it says here is count plus 1. Count is now 2. So 2 plus 1, you get 3. And while count is less than 100, count plus 1, then count turns to 3. And this part turns to 3, it prints out 3. This part turns to 3, you get 4. And then ultimately, when it gets to 100, it stops. So let's just print this out. And let's run it. And you can see it went from 0 all the way to 99, and then it stopped. Now, what if we wanted to do something fancier, right? What if we wanted to do something where it goes from 100 up to 1, and then instead of printing out 0, it prints blast off? So I want you to try that challenge, and I'm going to go ahead and do that right now. So you can pause the video, try it yourself, and then watch this part. I'm going to do this stuff in my terminal because I don't want stuff to freeze because it's really annoying, and then I have to redo the whole thing again when it freezes on rebel.it. So, but I will put all of these notes for you guys at the end of the day. So if I do a while loop, right? So let's try it from, you go from 100 all the way to 1, and then it stops. First thing I want to do is, since I want to print out from 100, I don't want count to start off from 0. I want the count to start off from 100. Another thing I have to keep in mind is, instead of incrementing, I have to decrement. So I have to account for my comparison operator flipping as well. So I'm going to do while count is greater than 0, right? Then do something. So I'll say while count is greater than 0, print count. And I want to do count is equal to count minus 1. Now let's give it a try. And you can see that it prints all the way up to 1, and then it stops. So that's good. Okay, now I want to write a statement where once it's 0, it prints off blast off. So let's write those lines of code again. So I'm going to say this. I want to say this guy. I want to say do this and then decrement. But I want to do something special this time. I want to say if count, whoops, let's just type it up again. Well, count is greater than 0. If count equals 0, I want you to print, see if you can catch the error in this logic, but print blast off. Otherwise, I want you to do what? I want you to print count, right? and I want you to decrement regardless of anything. So I want you to do count minus 1. So this part is not in the if else block because I want this part to happen no matter what we do. Okay, so I could either put it in my if block and in my else block, or I can just choose to put it outside, and that's what I've chosen to do. And you can see it grows from 100 to 1, and then it prints. Why doesn't it print blast off? That's weird, right? What's the logic there that it's not printing blast off? Well, let's think about it. We have this situation here, right? We have this greater than sign here. So the only way the body of the while loop runs is if this condition evaluates to true. Well, what does this condition evaluate to in this case? It evaluates when count is 0, this whole part evaluates to false, right? When count is 0, that part evaluates to false. If that part evaluates to false, the body of the while loop does not run. So when our count becomes 0 after it gets decremented on this line, then count 0 greater than 0 returns false, which means that this if condition doesn't run, therefore the blast off never runs. So we want to make sure that when count is 0, the body of the loop should run, this part should run, it should print blast off, and after that it should not run again. So here's one addition that we need to make to our code. Okay, so let's go back and type count this, right? The only thing that we need to add to our code is make count is greater than or equal to 100. Okay, and then everything else we can keep it the same. If count is 0, then I want you to print blast off. Else I want you to print out what count is, and then I want you to decrement count regardless, right? I want you to decrement count regardless of the situation. Let's run this, and you can see that it goes, let me make it bigger or something for you guys. And you can see it goes from 100 all the way, 100 all the way down to 1, and then ultimately it says blast off. Okay, so hopefully this gives you a little bit of a better idea of how while loops run. The codes will be down below. Thank you guys for watching. I'll see you in the next video. Hey guys, now we're gonna start the really interesting stuff. We're gonna start doing some problems, and so you guys can actually do it, okay? Now this is the part where you get involved into this process. So if you were passively learning up until now, stop now and start actively being part of this, okay? Because that's how you will truly learn. So let's start off by, I'm going to give you guys problems to do, but first I want to show you how it's structured. So then when you read those problems, you're not just sitting there like, what is going on? I want you to start understanding how to problem solve, and then I'll give you guys exercises that you can solve on your own, and then I'll provide you with solutions. So let's get started. Let's say I give you a function called sum2, okay? And it returns the sum of two numbers, okay? So let's just make it a little bit more clear. A function called sum2 that takes in two inputs and it returns a sum of those two numbers, okay? That's the thing, that's what it's saying. Now your job would be to break this down. So how I would break this down, and I would say, here's what the input does. It takes two things, let's call it num1, num2, or let's not be lazy and say number 1 and number 2. And then output is just number 1 plus number 2. Okay, so it takes those two numbers and it returns them. So it helps me break this whole sentence into something that I can code much easier. Okay, and then name of the function name is called sum2. Okay, So now I know what the output of it is, like, or kind of how it's done, what the input expects. Now I'm gonna try to see if I can create some examples of what it should look like. So I want to be able to say sum2, give it some number like 1 and 2. So this is how I'll actually use it, okay? And then my expected output should be 3. Right? If I take 1 and 2, if I give it 1 and 2, it should add it and it should return 3. All right? That's my expected output. Okay, so now let's get to coding this kind of function. If you give it something like 100 and then you give it 200 here, it should return 300. So here's how it works. Define sum2. I want to give it 1 and 2, or sorry, I want to give it number 1. I want to give it some number, another variable called number 2, and I want to say return number 1 plus number 2. All right, and now let's test it out. I'm going to give it, if you just define a function and don't do anything else, notice what happens when I run it. I get none. Nothing happened. It's like defining a variable. If I say x is equal to 5, it doesn't actually run and give you something. It just makes x 5. So function gives names to like blocks of code. All right, now let's print it out. Let's call the function sum2 on a number 1 and 2, and let's see if it matches our expectations, and it gives us back 3. Okay, now let's do it on another one, 100 and 200. Right, it gave us back 300. That's good. It's taking those two numbers and returns them. Well, how does it work? When we call the function with 100 and 200 as inputs, it goes back to the definition of the function, puts in 100 for number 1, right? It puts in this 100 for number 1 and puts in this 200 for the second number. So everywhere it sees number 1, it just replaces it with 100. Everywhere it sees number 2, it replaces with 200. Okay, so this happens and then this happens. Okay, it does 300. All right, that's the result of calling the sum2 function. So this part evaluates to 300 and then it puts that part out to the screen. Okay, and that's the same logic that gets applied for 1, 2. Okay, so this was the example. In the next video, I want to give you your very first problem. Okay, so I hope you're excited and let's go from there. Okay, now let's try our hand at our first problem. Okay, so I'm going to give you your very first problem this time. Okay, so let's go ahead into our course. This is on the main website. Okay, let's go to, or cleverprogrammer.com, that is. Let's go to the problem called square a number and let's click on it. And don't worry, if you're watching this on YouTube, I'll provide the notes below. So I'll give you the link to the problem and I'll give you a link to the solution as well. Okay, on the website, it's just all more integrated. So at the top, before you actually have to write your function, I have some notes here to help you out. So like, for example, I say something like, remember, functions always start off with the word def, which means define. So if you're ever writing a function, always start off with def. Note 2 says, don't forget your colons, okay? Note 3 says, always do return rather than print in your functions. Usually you do print to check if it's working correctly. Other than that, you want to do return. I'll make a video on return versus print so you guys know more in depth what's going on. So here is an example for you guys that we just did in our previous video, but I'll leave this here for every problem just so you guys can remember how it works. So remember the add2 function that we wrote, or sum2 function, it takes in two numbers and inputs and returns their sum. Well, this is how you write it. Define add2, takes in two inputs, we just call them A and B, and we return the sum of both of them. So if you look at line 4, it says it's now using the function. So that's an example of how to use your function. So print add2 1 and 2. All right, so 1 and 2 should give you back 3. Then it prints 3, and you get that result that you see right there where the arrows are pointing. Okay, now let's get to our actual problem. The problem is called squaring a number. Okay, you can read this on your own too, so I'm going to go through this a little bit fast. I want you to try this on your own. Hopefully you have taken a stab at this problem. After you have done so, this part is going to be the solution. Okay, so I'm going to go through the solution of this now. All right, write a function that squares a number, write a function square number that takes in a number and squares it. So right away, I know it's something like this. Okay, first part is done. The function is called square number, and I have to put a DEF before it. I also have to put open close parentheses because it's a function. Even if it takes no arguments, you have to put a parentheses, open close parentheses like that. All right, what else does it say? It tells me to take a number and square it, which means that I have only one input, right? So I know that I have one input and I have some integer, or I have some output, okay? Some number-based output. So I know my return statement, whatever is going to return, should be something that probably returns a number, okay? In this case, right, my output is going to be something like number squared, okay? So we are taking in one input. Let's call the input number, and let's just do return that number squared, okay? At the bottom, I have a bunch of testing things for you. So this part of the code actually tests your function. So it's a function called test square number that tests your function, okay? So just to make sure you got everything right, you should have a line printed out. If you've wrote this correctly, you should have a line saying your code is correct, okay? So to do that, you have to always uncomment the bottom line that I have here for you, which is the call to this function here, test square number, okay? So you want to uncomment that line below, and now let's run it and see if our code is correct. Okay, and you can see right here that it says your code is correct. All right, just to break it down, these two asterisks mean exponentiation. So I'm saying number squared, okay? How you would write it in math would be something like this. And then let's see what's happening, right? If you give me 2, you should get back 4. If you give me 8, you should get back 64. If you give me 10, you should get back 100. And now let's see how it works. So if I give you 2, right, this function call over here, square number 2. What happens? Let's write it down right here. Square number and give it 2. Okay, 2 gets passed in as the number. You have 2 over here. Everywhere there's number, the variable number, it gets replaced by 2. 2 to the power of 2, or 2 squared, just gives you 4. And so it asserts 4 equal 4, right? And then it gives you, and then it says it's good. How assertions work, this thing that I have that tests your code, is that if it evaluates to, like, it takes in some condition. If that condition evaluates to false, it throws a big error, right? If I said assert 5 equal 4 and I ran this, it's going to give me a big error at the bottom here, right? Parse error, but bad input on line 11. Oh, okay. It's giving me an error here, but let's fix this guy. Now it gives me an error on where I expected to give me an error, on line 14, which says assert 5 is equal to 4, and it says no, that's not true. But if I had 4 equal 4, it would just pass it quietly, meaning like it won't do anything. So if it doesn't give you an error, it means that thing is correct, okay? And that's it. That's our solution for this problem, square a number. In the next video, we're gonna solve the problem of checking if a number is even. All right, so try it on your own, and in the next video I'll have the actual problem for you guys, and I'll have the notes below, and I'll have the link to solution below as well if you're watching it on my YouTube channel. If you're watching it on my website, then there won't be anything below because everything is actually part of the cleverprogrammer.com website. All right, I'll see you in the next video. Okay guys, now let's talk about a new problem. All right, so I just clicked this part that says check for even number divisibility. Again, if you're on YouTube, you're gonna have the problem notes below and the solution notes below as well. So no need to worry, but this is on cleverprogrammer.com. So let's keep going. You can write a function, the problem says write a function is even that takes in a number and returns true if it's even, otherwise it returns false. Okay, so before you watch the solution, take a stab at it and try to do this problem, okay? And after you're done trying and you're pulling out your hair, you're like, oh, I can't do it, come to watch the solution, okay? I've given you some hints here as well. So think about what does it mean for a number to be divisible by another number, right? So what does it mean? Let's test it out a little bit. So if I have 10 and I want to check if it's divisible by 2, well, what does it mean to be divisible? It means remainder is what? Right? If I do 10 divided by 2, what's my remainder there? Right? So my remainder here will be none because 2 goes perfectly into 10. And there's a way to check for remainders, okay? So for example, let's check if 3 goes into 12, right? So if my remainder is 0, then that means 12 is divisible by 3, right? I can also try it like this, 12 divisible by 3, and see if this gives me true or false. If it gives me true, well then 12 is divisible by 3. If it gives me false, then 12 isn't divisible by 3. Okay? So that's your hint. I've given you your example here as well in written format. And then I have a bonus challenge for you, which says if I give you a number and you check that it's, if it's even, and your function checks it's even, so that for that function, the challenge that I gave you is see if you can write it in one line of code. Okay, but don't try that first. Try to do it with some if-else statements. So it's going to get you to do some if-else statements. Okay, now let's go over the solution. So the first thing I want to do is write, what's my function name? Is even. Okay, it says right there, is even. Another thing that you can do to trick the system is if you look at my test notes below, well, it kind of tells you what the function is called and how it's expecting to use the function. This is how the function is going to be used, right? You're going to say is even and pass in a number. And either it'll give you a true or it'll give you a false. So I have test cases here written for you. If your function runs correctly, all these test cases are going to give you a big thumbs up and the screen is going to print out your code is correct, right? So let's say that I give this, some number. And basically, what do I do? If number is divisible by 2, right? That's how you check if it's divisible by 2. If you just do this, that'll give you the remainder. So this will evaluate to 0, okay? But you want something to evaluate to either true or false, okay? So number mod 2 should give you 0. This means that number should be divisible by 2. That's what it means to be even, right? 2 should be able to go inside of that number. Return true, else return false, right? If 2 does not go inside of that number perfectly, then I should get back false. So like if I tested, 13 divisible by 2, check if it's divisible, it says false. Well, I can even check out what's left over. 2 goes all the way into 12 and then 1 spills over and you get a remainder of 1. Hence 13 is an odd number and not an even number. Just in case you don't know what odd and even numbers are, 0, 2, 4, 6, 8, 10 are all evens, and then 1, 3, 5, 7 up to infinity are all odds. You can have negatives and positive odds or negative and positive evens. All right. I also have the notes on my website for you guys to help you So remember it tells you how to write a function, it tells you where to put the colons, it tells you to return things, and it gives you an example of the add to function as well. So let's test it out. I'm gonna comment out line 43, and I'm going to run this, and if it prints out your code is correct, then our code is correct. Otherwise, it's wrong. Okay, good. It says your code is correct. Now I'm gonna go over the bonus challenge. Okay, so define bonus challenge, kind of, or actually I can just do it right here, because you guys can pause the video and stuff, right? So you guys can go back in time as well. Return, and what do I want to do? Number divisible by 2 is equal to 0. And that's it. You don't have to do if, you don't have to do else. It does it all in one go. Well, what happens here? If the number is divisible by 0, if the number is divisible by 2, it'll give you a true. If it's not divisible by 2, it gives you a false. So you don't need to check if this, then true, otherwise false. It kind of does that for you. So that's your one-liner, okay? Hopefully this video was helpful for you and you learned something. In the next video, we're gonna find out how to find the length of a string. So that's a problem that is gonna be really cool, and you will be able to try it out. Check out the show notes below so you can practice this and also try to solve this problem, the check for even numbers. Take care. Hey guys, so in the last video I mentioned we're gonna do find length of string, but what's better for you guys is if we do another problem that's pretty similar, so you guys can test out your own skills as well, just in case you got stuck on the even number problem, right? So let's see if you can write code that can give you an answer for the if the number is odd. Okay, so this problem is called check for odd numbers. All right, so here I have write a function is odd that takes in a number and returns true if it's odd, otherwise false. So it's pretty much the opposite of finding an even number solution. So with the even number problem, if I gave you 2, it should return false, right? Or I'm sorry, it should return true. But for the, whoops, it's all really loud. So same thing should happen for this one, except when I give you 3, it should say true, otherwise false. Now I'm gonna go over the solution to this problem. Just in case you haven't tried this on your own, the link is below to the problem and to the solution. So if you're watching this on YouTube, go ahead and try it on your own. If you're on my website, cleverprogrammer.com, everything should be a-okay anyways then. So let's get started. I have some function, it's called is odd. That's the first step to get correct. And you can check how it works here at the bottom. So again, you can just go ahead and kind of cheat. You see the function is called odd. It takes in one input, so you can kind of go like, okay, is odd, my input is some number. And what can I do? If that number, what does it mean for a number to be odd, right? What does it mean for a number to be an odd number? Well, all it means is that it's not divisible by 2, right? So for example, if I gave you 12, right? Is it divisible by 2? Yes, it is. You get back true. But what if I give you 13? Is that divisible by 2? No, because 2 goes all the way up to 12, and then there's a 1 spillover or remainder. So here you have false. But we just want to flip the results, meaning this should give you false and this should give you true for the solution to this problem. So let's go. If number divisible by 2 is not equal to 0, then I want to say give me true. Otherwise, give me false. Okay, let's check if this solution works. So I'm gonna uncomment this part and let's go and run it. And it says your code is correct, so that's good. Let's try giving it, is odd. Let's try giving it 3. It says true. And what if I give it 2? It should say false. Okay, cool. And now, if you want to try the bonus challenge on your own, pause the video, go try it. Otherwise, I'm going to go over the answer right now. So here's the bonus way of doing it. Return number divisible by, or mod 2 does not give you the remainder of 0. Okay? So it's like the opposite of the even number function. So there you go. That's your one-liner, right? Your cheeky one-liner. Okay, guys, that's it for this video. I'll see you in the next video. Guys, what's up? This is Kazi from cleverprogrammer.com, where you learn to code smarter. In this video, what I want to talk about is string length function. I don't know why I did that actually. But essentially how this function works is that if I give you something, I don't know what's going on with my hands today. If I give you something, a string, and you tell me how many characters are in there, okay? So by now, hopefully you should kind of know the format of how these problems are laid out and how you can solve them. And you can also look at the tests, like the cert tests that I have to kind of cheat, right? Like, oh, this is how many inputs it takes in and yada yada. Okay, so try this problem on your own. I have the notes below in the YouTube video. I have the exercise solution below. And if you want to, you can go to my website, cleverprogrammer.com, and enroll in the course so that you can keep track of everything. And then, you know, it's all nice and all in one place. Anyways, let's keep going. So I'm going to write the solution right now. So spoiler alert, close your eyes, kids. If you haven't tried it, do not look at this. You don't deserve to look at the solution if you haven't tried it on your own already. Okay? Go try it on your own. Let's get to the solution now. So first thing I'm going to do is def because it's a function. Then string length because that's what I told you the function name should be, right? Write a function that takes in a string and returns its length, right? So the function is called string length, right? Inputs. How many inputs does it take? That takes in a string. So the word should give you a hint that it's only one thing. You can say string, you can say my string, you can call it whatever you want, okay? I'm just gonna call it my string to let you guys know that there's no special meaning behind the word string itself, so you don't need to like know what it does. What this function requires you to know is how to do a for loop, okay? If you can do a for loop, you can solve this problem very easily. So I have my string. Now what do I wanna do? I'm gonna run through that string and count each letter, right? So if it's hello, I want to count that. I want to keep track of every letter that I see. So when I see an H, I hold my finger up like this, like 1. When I see an E, I go 2. When I see an L, I go 3. I see another L, I go 4. When I see an O, I go 5. And if I've run out of characters, I want to just output 5. Okay? So it sounds like something that I want to run multiple times. Sounds like a loop. For letter in my string, right? If I do print letter here, you guys can see on the right hand side that it's going to go through that and it's going to print the letter. I have to call the function, of course. String length, and let's give it hello. And let's run it. And on the right hand side, you can see that it goes H, E, L, L, and O, right? That's great. So we have access to each character. Now what do I want to do? I want to have a tracker variable like count. Okay, and I want to set it to 0. And every time I see something, I want to increment it by 1. So count is equal to count plus 1 or count plus equal 1, because it's such a common operation. So we just increment by saying plus equals, okay? That's how you're going to see it written down in Python pretty much everywhere. And if you're programming in some other language, like C or C++, you're going to see it written like this. All right, so I have count equals count plus 1. So I'm incrementing count by 1, right? Increment count by 1. And how many times do I want to print out count? Every single time or just at the end? If you think of that question in English, you can answer that very easily. I only wanted to return the count once. So should it be part of the for loop or should it be outside of the for loop? It should be outside of the for loop. Good. Okay, and I just want to hit enter so it looks nice. And yeah, now let's try this. Let's do print and my function, right? Let's see if it prints 5. Okay, it prints hello, and then it prints out 5. We don't want to print out hello anymore because we know it works just fine, and you get 5. How does it work if you really break it down? Well, to my function, I pass hello, right? So this part of my string becomes hello. Then this becomes hello. The first time we're going through the loop, this is an H, right? Then we just count it by 1. Then the next time we go through the loop, this is just an E. And then we count it by 1. Then next time we go through the loop, this is an L. Then we increment by 1. Next time we go through the loop, it's L again, and we increment count by 1. And then last time we're an O, we increment count by 1, and now count is 5, and then we return 5. Now, if you notice, do we use the variable letter anywhere else? No, we don't really use it. So you can say whatever you want here, or you can just put an underscore here because we don't really use it anywhere, so we don't care what that variable is. But sure, we'll just leave it as letter. At the end of the day, I wanted to return count. Now let's test our function. If it prints out your code is correct, then our code is indeed correct, and we are done. Let's check it out. Oh, whoops, I can't hard code a value here. I have to change this to my string. And let's run it, and it says your code is correct. Now guys, we're learning all of this to build something big, okay? We're gonna build our own rock, paper, scissors. And I don't mean like codecademy.com, let me hold your hand and here's the entire code and you feel like you did it but you didn't really learn anything. I mean, you're gonna be doing practically the whole thing. I'm gonna give you the bare bone pieces, but you're gonna be writing your own code. And I really want you to be able to do this completely on your own. So it's really important that you do all of these exercises and try your best to do them on your own, because you will need all of these pieces to then go and try to build your own game. So we're gonna start off with a simple game like rock, paper, scissors, but then after that, we're gonna do something with Twilio API, which is the text messaging. You can build pretty much your own text messaging app, okay? And you can actually send people text messages on their phones. So we're gonna be doing some really big stuff here, all right? No more baby stuff. But I want you to be prepared for that. That's why I have this for you guys. I have notes, I have solution notes and everything. So take advantage of that. Use everything at your disposal. If you haven't already, subscribe to this channel and do not miss the next video, because in all of those videos that are coming up, we're going to be covering really important things. I'll see you there. Hey guys, this is Kazi from cleverprogrammer.com, where you learn to code smarter. So let's get started. I want to cover last letter of a string function in this video. Okay, so how do we play around with the string so we can get its last letter? That's the function I want you to write. It should be very simple. You should be able to get it pretty fast. If you look at the tests below, if you use the last letter function, pass it hello with the exclamation mark, it should give you the exclamation mark. If you give it banana, it should give you an A, because A in this case is the last letter. If you give it something with only one letter, it should return that letter. If you give it, again, funny guys, S, you get the idea. So let's code this bad boy up. Again, you do not deserve to view the solution if you haven't participated and try to do it on your own. You gotta be part of actively learning, okay? I don't want you to be passively learning, like just sitting back, like eating some popcorn. I don't want you to do that, okay? While I do agree, this is kind of like Netflix for your career, but I still want you to be actively learning, okay? It's like Netflix that you engage in and participate in, all right? So let's get to coding this bad boy up. Notes are below, solution notes are below, exercise problem is below, everything is there. Let's keep going. Define last letter. Okay, Now, what does it take in? It takes in some string. So you can literally call it some string if you want to, but we're just going to call it string. What does it do then? Well, it's very simple. It returns the last letter. How do you return the last letter? If I opened up a terminal and showed you guys how this bad boy works, quite simple. If I have a string like hello, to get its second letter, I would do this. To get its third letter, I'd do that. To get its first letter, I'd do this. But if I wanted to get its last letter, there's a trick in Python that you can do. Index by negative numbers. If I do -2, this gives me the second to last letter, which means I'm going to get the second L, okay? Hell, last L of the word hell. But if I want to get the last letter, well, I can just do this, right? This gives me the last letter. Now let's code this up. Return string and last letter, okay? As simple as that. Let's test our function and prove to ourselves that we are indeed correct. And it says your code is correct. Okay, that's it for this video. If you watched up to this point and you haven't subscribed right now because you don't want to miss the next videos. I will see you there. It didn't end. Let's try it again. Hello there, my beautiful friends. In this video, I want to talk about who's the bigger guy. This is Kazi from cleverprogrammer.com, and we're going to solve a pretty sick problem. Sick as in good. Now, this problem essentially wants you to find max of 2 numbers. So if I give you, look at line 19. If I give you 1, 2, you should return 2. If you give this function, bigger guy function, if you give it 10 and 20, it should return 20. If you give it 20 and 10, it should return 20. And if you give it 2 and 1, it should return 2. Get the idea? And same thing with the strings, but you don't have to do anything special. Python knows how to check strings against each other, okay? So let's code this up. Notes are below, solution is below. I think you guys know the drill at this point. If you're watching this on YouTube, that is. If you're watching it on my website, everything is going to be there in your face. So, first step, DEF, define. We're writing a function that does this, right? Look at the instructions. Write a function bigger guy. So, I know that I do this with my eyes closed. Now, what does it take in? It takes in 2 numbers. So, I know that it takes in 2 inputs. I can say num1, num2 or something, okay? And what can I do here? Well, I want to check between those 2 numbers, and whichever is the bigger one, I want to return that number, right? So using if statements and comparison operators, we can do all of this together. If you haven't solved this yet, or if you haven't tried to solve it on your own, please don't watch this. Pause, try the problem, then come back. But here's the solution for you guys, for you eager beavers. If num1 is greater than num2, return num1, right? If num1 is bigger. Well, otherwise, return num2, right? In the case where num2 is equal to num1, do we care which one we want to return? Of course not. We don't care. We just want to return any of them. It doesn't matter. Okay? To specify that for you guys here, I'll be nice and I'll add in another test. Okay? 10, 10. It should return 10. I really don't care what it returns in the case where their 2 are the same. Okay? And what if num2 is the one that's greater? Well, in either of those cases, right? The first case, we return num1. If it's the case where they're equal, or if num2 is greater, we return num2, which is why we don't need to give a condition. We just say else and we're done. Now let's check this bad boy and let's see how it works, right? Let's give it some. Okay, here I'll just do it to be extra tangible here for you guys, right? So let's do 3, 5. It returns 5. Let's give it 5. 9, it returns 9, and if I gave it 5, 5, it should return 5, right? So we know what it does. And here, let's uncomment this line. And when I run it, it should say your code is correct, which means that it passed all of these assertion tests. And then at the end, it said your code, then it went and said your code is correct. Now, what if, all right, I'm going to save that for the next problem, because next problem is going to be a lot more fun and more challenging, where you're going to have to solve the biggest guy. So if I gave you 3 guys, what do you do? We're going to discuss that in the next problem. If you haven't already, subscribe. I'll see you in the next video. Hey guys, this is Kazi from cleverprogrammer.com, where you learn to code smarter. In the notes below, the problem, who's the bigger guy, is there. So take a shot at it. The solution is also there. But we're going to walk through the solution right now. So let's get to it. I'm sorry, the biggest guy. Who's the biggest guy? Okay. So essentially, if you read the problem, it says write a function, biggest guy, that takes in 3 numbers as input and returns the biggest one. So I take 3 numbers and I find whoever's the biggest and then I return it. Okay. So this one gets more challenging, and if you've tried it on your own, you'll notice there are a lot of if-else statements that you're doing. Also, on line 8, I have a bonus challenge for you guys. It's a write a 1-line solution, okay? What I mean by that is like 2 lines, right? Because you have to have 1 line to define the function, obviously, and then you have to have 1 line for the solution. So that's what I mean by 1 line, okay? Now, it's medium to hard difficulty because you guys haven't done anything like this before, so it'll be challenging if you want to do the bonus challenge, and I'll go over that as well. First, I'm going to go through it the normal way. So let's define a function called the biggest guy that takes in 3 numbers a, b, and c. Okay, or we can call it num1, num2, and num3. Okay, now the approach that I want to take against this is I want to find who's the bigger guy between num1 and num2. Okay, so find bigger guy between num1 and num2. Then after finding the bigger guy, compare. After finding the bigger guy, I want to find bigger guy between. Or let's just say biggest guy, right? Between big guy, bigger guy, and num3. Okay, that's kind of the approach I want to take. I want to find who's bigger between num1 and num2. And then once I find these guys, right, I'll find like the bigger guy kind of. Bigger guy. Then I want to check the bigger guy against num3 and then see who's the biggest, okay? So with that pseudocode / English written formula, let's go ahead and try to code this up. So if num1 is greater than num2, then bigger guy is equal to num1, right? Else bigger guy is equal to num2. Okay, and so now I have found the bigger guy. Now I just have to compare the bigger guy with num3. Okay, so if bigger guy is greater than num3, then biggest guy is equal to bigger guy. Else biggest guy is equal to num3. Return num3. Okay, I haven't tested this function yet. Hopefully it's right. Let's comment out line 44, which tests our function, right? We want to run this function because these are the tests I've written for you guys, and it allows you to test your functions. And if we give it 1, 3, 2, it should return 3. If we give it 30, 10, 20, it should return 30. If we give it in any order, it should return 30. If we give it strings, it should also know what to do. Don't worry about that. You don't have to do anything extra. That's just to trick you guys. Python knows how to compare strings, okay? So let's take this bad boy out for a run. We got an assertion error on line 44. What's the error? Did we like not write this correctly? What's going on? Test biggest. It should be called guy. I don't know why I have by guy. But what's the assertion error? Oh, right. Yep. Return biggest guy. Duh. Okay. Boom. There you go. Success. Your code is correct. Okay, so it says I'm running tests, and then it says, good job. Your code is correct. All right. That's it for this one. Now let's try to change this and code it up in a better way. Okay, let's code it up in kind of like a one-line solution. So the one-line solution, I'm kind of cheating. It's not really a one-line solution. What it is it wants you to kind of use your previously written solution, okay? So you can say define bigger guy of num1 and num2, and you can say if num1 is greater than num2, return num1, else return num2. Okay, so remember, this was the function you wrote for bigger guy. So now let's use that function to do this problem. Here's the nice solution. So I can say return bigger guy num1 comma num2, and I want to actually call my function here again, bigger guy of num1 comma num2, and then compare that against num3. So if I run it, it again says success, your code is correct. Now how does this work? Well, I want you to pause the video and try to think of it yourself how it works. But now I'm going to go over how it actually works. Okay, so this is a really nice problem here. It is allowing you to use functions within functions, okay? Well, I have this guy here, right? So what can I do with this? When I pass it like one, let's say I have 1, 3, 2 here, right? Those are the inputs I pass it in. As you can see on line 32. 1, 3, 2. So what does this do? It calls the bigger guy function with 1 and 3. Using the bigger guy function, it finds the max of 1 and 3. So this whole thing evaluates to a 3. Then it tries to find the bigger guy between 3 and num3. Num3 is 2. So then we just go back to this function and find the bigger guy between 3 and 2. And then this function will return 3, and that's your solution. Notice this is the key here, the notes, right? Find bigger guy between num1 and num2, and then find the biggest guy between bigger guy and num3. Okay? So let me go back and put it like this. These notes will be here for you guys when you guys are reviewing the video. This is the solution. Okay? And that's it. We're getting closer to starting to now work on projects. So like the Twilio API project, where we will be kind of coding up some stuff and you can actually make a text messaging app through that. And then we will also be getting to do some make some games like rock, paper, and scissors. Okay, so all these functions are very important for you to learn, so then you can actually use these things when you're writing your own code. You know how to think in the correct way. One thing I want to reveal to you guys is Python has a built-in function called max that kind of does this and finds the biggest number. All right, so you can actually just say max of num1, num2, num3, and I can prove to you it works. As if I return, look, it says, if I run it, which I'm clicking it right now and running it, it just says success, your code is correct. So max is a built-in function that finds the maximum between any numbers you give it. Okay, thanks for watching. If you haven't already, go ahead and subscribe right now. I'll see you guys in the next video. Hey guys, what's up? This is Kazi from cleverprogrammer.com, and we are going to be working our way up to tic-tac-toe. So this is going to be one problem that I'm going to give you before I put you guys onto tic-tac-toe project, because once you do this, you'll have a better idea of how to complete that project, okay? So this is going to be a pretty important video, and after this, you guys will be ready to write your very own first game. And what I've done for you guys is essentially, it's not just going to be a boring text-based game. I've created a full GUI for you guys. So once you complete the code and complete the functions, the whole GUI application will work, all right? So without any further ado, let's get started on the helper assignment I created for you guys. So this assignment is called Usain Bolt races you and Kazi. Okay, so here's the backstory. Usain Bolt, you and Kazi had a race. Okay, surprisingly, Usain Bolt won. I don't know why. And then you came in second, and for some reason, Kazi just sucks at running. So I suck at running somehow, and I came in third. So I didn't do too good. All right. Now, can you write a function that given a person's name returns their place? So for example, if I gave you Usain Bolt's place or Usain's name, so I just said Usain, you give me back 0th place, or sorry, 1st place. If I gave you, like, if I type in you or me in your case, I would have you write me, okay? So like here, if you see the test case, so if I give you me, then you should return 2nd place. And if you put in Kazi, it should give you 3. All right, that's how your function should work. And can you also write a function that does the opposite? Given a place, it returns their name. So maybe your function will be called number to choice. And if I give you 1, you should give me back Usain. And if I give you 2, you should give me back me. When you're writing and typing this code, me will really be you, right? And if you give the function number to choice 3, it should return Kazi's name, okay? So my name. If it works, then you get back a nice little graphical GUI thing that I made for you guys. You'll have a turtle that'll make a nice little circle and say, good job, okay? My graphics are getting next level, okay? So give this function a try. See if you can solve it. See if you can solve choice to number and number to choice. Okay, those are your 2 functions. So essentially, if I give you here, then you should say, okay, that's 2nd place. If I give you Usain here, you should return, okay, that's 1st place. And here, if I give you 2, you should return your name. Or sorry, not your name, but you. And I'm sorry, I'm confusing you guys. It should return me. If I gave you 2, this function should return me, okay? You can look at the test cases, and that's what they say. This whole me and you thing is kind of confusing. But if I give you 3, it should return Kazi, all right? Number. So I'll leave that there. So in this, I've already written the function name for you, and I've already written the argument names for you to make your life easy, all right? What you have to do is complete both of these functions, and then go at the bottom and uncomment this line. If I uncomment it right now and try to run it, you can see it says incorrect, keep trying. If I run it again, it'll say incorrect, do not give up, which means that my code is incorrect, all right? Once my code is correct, it's gonna make a nice little green circle and say correct, good job. So if you've not given it a try yet, go give it a try. Otherwise, I'm gonna go over the solution right now, okay? So let's get started. So how will we write the choice to number choice function? All right, so let's write it up. If choice is equal to Usain, then return 1. Else if choice is equal to Kazi, or sorry, me, return 2. Else return, or let's actually just do else if choice is equal to Kazi, return 3. Okay, so that will essentially do what we want. If I try to print here and go print choice to number and give it Kazi, right? Let's see what it does. Let's run it. You can see that it gave us back 3. That's exactly what we expected because I came in third. Now, what if I gave it me, which is going to be you when you're writing this function? It's going to say 2. Okay, that's exactly what you want. And let's say we give it Usain, it says 1. Okay, so it's working correctly. That's exactly what we want. But is there an easier way we can do this function? So there's if, else if, and else if that we wrote. Is there a way we can make it easier, perhaps using dictionaries that we learned earlier? Remember, we have choice, and that's associated with, we have this thing here, and each choice is associated with the value, with the number. So this should automatically be telling you guys like, hey, maybe there's a key value relationship. If you put in 1, you get back Usain. If you put in Usain, you get back 1. If you put in me, you get back 2. If you put in Kazi, you get back 3. So what we can essentially do is rip this whole thing down and replace it with the data structure that does it for us, right? It's called a dictionary. So I'm just gonna say choices. What should I call it? Let's call it race dictionary for now, okay? To keep things simple. And I'm gonna say if given Usain, I'm gonna write it on. Actually, let's just keep it simple. Given Usain, return key. Usain should be the key, and the value should be 1. Me. Key is me. Value is 2. And then Kazi. Key is Kazi, and what is the value? Value is 3. So then we can say return race underscore dictionary, and we can index it by the choice that's given to us. So for example, if you put in Usain here, it's gonna look through this dictionary, right? What's the way that dictionaries work? It's dictionary, you index it by its key, and then it returns the corresponding value. So here, race dict is a dictionary. We index it by the choice. So if the user gives us Usain, it'll put in Usain here, and that'll return, this whole thing will evaluate to the value. So in this case, 1. Same thing will happen with the rest of them, okay? So hopefully that makes sense. And can we simplify this? Yes, we can. Do we really need a variable that we're just gonna use like a second later? Not really. And it doesn't make our code any dirtier or any harder to read. So in this case, you can just do this and it's done. You can assign it a name if the dictionary was really big, but here the dictionary is pretty small. We don't need to use an extra variable here. So I think this is good. And let's use the same idea here, and we can say return if given 1, return Usain. Oh, by the way, let's test it. Okay, that's a good thing to do. Let's run this here by hitting run, and let's see what we get. And we get back 1. That's what we expected. Let's put in me here. Let's see what happens, and we get back 2. What happens here? We pass in me to the choice to number function, so we really pass in me like this. It goes in, it indexes this dictionary by me, right? And me has a value of 2, so this whole thing evaluates to 2 and it's done. Okay. Let's hit it run and it returns 2, so it's working. And let's do the same thing for number to choice. Return 2 would return me, and then 3 should return Kazi, right? And we index it by the number because this time number is the key, okay? So, okay, it looks good to me. Let's uncomment the line 67 and see after it, does it pass all these tests I've written here, right? Does it given Usain return 1, given 1 return Usain, and all that? Let's run it. And it passes all the test cases. And on the right hand side, you see it made a nice little green circle with the turtle, said good job. And so we are Done. Okay? Awesome. If you guys didn't get it, no worries. If the dictionary thing was new to you, perfect. This is all supposed to be new for you guys. Now, these concepts are going to be directly applied in the next video where I'm going to have the tic-tac-toe project for you guys. I have the notes for it, I have the solution guide for it, and I will help you guys build the whole thing on your own, and it'll be something that you can proudly share with your friends, family, whoever, okay? Your girlfriend, boyfriend, doesn't matter. It's going to be something that's going to actually work. It's going to have a link that you can share, and it'll directly be playable. So I hope you guys are excited for the next video, and I'll see you guys there. Hey guys, what's up? This is Kazi from cleverprogrammer.com, where you learn to code smarter. Let's jump right into it today. All right, we're gonna be building the tic-tac-toe project. I am so excited for this one. I've been building up to this for so long, and now you guys are gonna be on the same page with me, and we're gonna build a tic-tac-toe game. All right, so let's just get started. So let's come here. And before I start talking about any of this, let's just start off with what it's going to look like when you're done building it, okay? And you're going to be able to share this with everybody. So it's going to be pretty simple, and here's what it's going to look like, all right? Not the fanciest thing you've ever seen, but hey, it's something. So you have three choices: rock, paper, scissors, and you're playing against the computer, okay? So let's say we picked rock. The computer picked paper. What just happened? Well, paper beats rock, and so if you look at the computer score, he got 1, and you still have 0. You, my friend, are not a very good rock, paper, scissors player. Let's try again, all right? We have to beat the computer, so let's go. Rock, that's a tie, that's pretty good. I think that since the computer already picked rock, he's probably going to pick scissors next time. So to prepare for scissors, I'm going to pick rock. Boom! Okay, so that was pretty awesome, but that was not planned. The game is not rigged at all. It's supposed to be random, but I'm pretty good at reading random computers. Let's see. He picked scissors, so maybe he's going to pick scissors again. Let's stick with rock. Oh, he picked rock. Paper. Okay, so he picked rock. We picked paper. We won. We have a score of 2. The computer has a score of 1. We can keep on going forever, but I'm going to end it for now. Okay, so now let's talk about the actual project and what you need to do to get it to work. As you can see here, I have hidden these functions from you. So choice to number, number to choice, random choice number, and choice result. Those are the only 4 functions that you need to complete in order to complete this entire project. Everything else I have done for you. So you don't need to touch anything else. Okay, you pretty much just need to complete those 4 functions, and when you're done completing them, your entire game will run. Another thing I've done to help you out is I've added some tests. So if you uncomment line 73, this line right here, and run it, and if your functions pass the test, then most of your functions are correct. Some of the functions it's hard to write tests for. For example, random computer choice. If you're randomly generating choices, it's kind of hard for me to test it. All right, so that one you kind of just have to do it correctly. All right, further explanation of the project. So you have choice to number function. What does that want? Well, let's say I give you rock, you should give me back 1. If I give you paper, you should give me back 2. If I give you scissors, you should give me back 3. All right, what's the number choice function's job? Okay, well, if I give you a number like 1, you should give me back rock. If I give you 2, you give me back paper. And if I give you 3, you give me back scissors. Okay, so both of those functions complement each other, okay? They're kind of the inverses of each other. Now, let's talk about random computer choice function. What does that do? Well, the computer needs to be able to generate random choices, okay? So we need to use the random module that I've imported on line 5. I have also added some hints for you guys on how to use the random module. So here, if I show you guys the problem, I have added some hints for you here, okay? So random computer choice. So I want you to look up what random.choice does and how to use it. In my solution video, I'm going to go through the whole solution. So if you couldn't figure it out, you're going to learn anyways. But I want you to be able to exercise some researching skills and develop your programmer's ability of like solving things by researching it on Google or Stack Overflow or something like that, all right? Because that's important. A lot of the times I'm on Stack Overflow or Google trying to figure out a problem. So figure out how to use random.choice to make the computer randomly choose between rock, paper, and scissors. Okay, let's go. So it's just to give you a hint, it's going to be a one-line solution, like return random.choice and then pass in rock, paper, scissors. The computer's going to return one of those every time. Okay. Now, the choice result function is going to be the meat of the project. It's going to be the whole logic of the project is pretty much going to be here. So what's going on here? Well, you have a computer score and human score, which is up here. The global variable, maybe I'll explain that. I'll explain that to you guys definitely in the solution. But for now, let's not worry so much about it. Just focus on not removing these lines. When you come down here and you start coding this up, well, essentially what you're going to be doing in choice result is you're given the human choice and you're given the computer choice. So using that, you figure out who won. So for example, if human choice was rock and computer choice was paper, well, paper beats rock. So in this case, computer should win. So actually, this should actually be this. Computer score is equal to like that. Okay, so I'm sorry, I had it wrong. I'll fix it up. When you guys get the link, you'll have the fixed version. So since paper beats rock, computer score should be incremented by 1. Where's computer score? It's right here. Human score is also right here. Okay, so then you can check, hey, if computer choice was I don't know, whatever, then you can increment based on that. But what if it was a tie? What if they both had the same thing? Well, in that case, you don't have to do any incrementing. You can just print tie, or you don't even have to check for that condition, okay? So that's the simple answer to that. How you're going to do choice result, entirely up to you. I would suggest doing bunch of if, else if type of statements, okay? So you're going to have a bunch of if conditions. You're going to check rock against paper, paper against rock. What if human picks this and the computer picks that? So you get to exercise some of your if-then statements. There is a clever way of doing it, which I will explain to you guys in the solution video. But for now, just use your if-then type of statements to do this, okay? Choice to number, number to choice. I've kind of given you guys an example of how to do it. So you guys should be good on that. And other than that, I think you guys, let's see what else I need to explain here. Test all, yep, just uncomment this and test some of your functions. You know, if you give choice to number, if you give it rock, it should return 0. If you give it paper, it should return 1. And, you know, on the other hand, vice versa, pretty much. Number to choice, if you give it 0, it gives you rock. If you give it 1, it should give you paper. Everything else helps you, all this stuff at the bottom it helps make the GUI, the graphical user interface of the project, and it wraps up your logic in and makes it a part of the game. Okay, so here if your code is not completed and you try to run the game, you're gonna get back some stuff that doesn't make much sense. Okay, so it's not gonna make sense. But once you complete all of these functions, the whole game is gonna work perfectly, and you're gonna have essentially the game, and it's gonna look like this. Okay, all right guys, hopefully that explains the entire project and what you need to do. Hopefully you have all the tools that you need to put this together and make the game. If you make the game, please put your links, share your links using CodeSculptor. You can click this button here that says save, and when you hit save, it generates a new link for you at the top. Okay, so if I were to bring this guy down, you can see it brought this link for me, and you can go to that link and then see the entire code or play out the entire code. Okay, sorry about that. Let's just bring this guy back at the top. All right, so that's how that works. You generate that link. post it in the comments below. Some of the things I want you guys to watch out for is if you hit Command R or refresh, it just removes the whole thing. You have to be careful because Code Sculptor is in the browser and it doesn't save your code. So if you hit save, it'll give you that link and that link will help you. But if you don't save and you hit refresh, then all of your code just kind of goes away. So watch out for refreshing randomly. And yeah, so save continuous, save a lot, okay? Save constantly, and then copy that link constantly so you can have that link just in case something bad happens, okay? And maybe even put this code locally. It gives you a download button. So every few hours you're working on this, maybe hit the download button so you can download it locally. That way you're not in the risk of losing it, okay? After this, we're going to work on some other really cool projects. I have that in mind. But for now, focus all your energy on rock, paper, scissors. Let's get it done. Post your codes below. Post your links below. I'll have the notes to this problem below. And I'll have the solution to this problem below if you're watching it on YouTube. Okay? If you're not watching this if you don't want to watch this on YouTube and do it directly on my website, cleverprogrammer.com, go ahead and enroll in that school. And there you can keep track of all of your progress. And you can go there and all the resources will be there readily available. All right, guys, good luck, and I'll see you guys in the next video. Hey guys, what's up? This is Kazi from cleverprogrammer.com, where you learn to code smarter. So here we are finally finishing up our rock, paper, scissors. Thank God I can say it correctly finally. I'm so sorry. I've been calling it tic-tac-toe the whole time. I don't know why I keep calling it that, but hopefully in this entire video, I'll say rock, paper, scissors. And if I say tic-tac-toe, I'm probably talking about rock, paper, scissors. So with that disclaimer out of the way, let's go ahead and talk about the solution of rock, paper, scissors. Hopefully you guys got to try it. And yeah, so let's just get right to it. So here we have the game open, and I have the solutions here for you guys. Now, having the solution here for you guys is great, but what I want to do is I want to walk you through it one step at a time, okay? So let's go ahead and walk through it. All right, choice to number. So if you did the previous problem, the Usain Bolt video that I made, which is essentially you get a person and you have to number them and which place they get. So if I give you Usain, you give me back 1. If I give you me, you give me 2. I give you Kazi, you give me back 3, right? So let's apply that same thing directly here. So given a choice, we want to convert it to a number. Okay, so let's say that we were given a choice. Whoops, sorry about that. Okay, so let's say we were given a choice like rock, you want to give me back 0. If you're given paper, you want to give me back 1. Now, certainly you can say if choice equal rock, right? Choice is coming from here, which is the function. And if choice equal rock, then return 0. You can certainly do that. But a better way to do it is, since we know we have a relationship between two things, we can use the key value pair technique. So the way that I would write the solution is I would say RPS dictionary, and I would say if it's rock, give me 0. If it's paper, can't type, paper, goodness. All right, here we go. And if it's scissors, give me back 2. All right, and then what we want to do is we want to say return RPS dictionary and index it by the choice passed in. So for example, if choice is rock, it goes to this dictionary, RPS dictionary, it indexes it by rock, so it goes and looks at this key and it returns a corresponding value. So this whole thing evaluates to 0. Okay, so that's essentially the idea. And since we're declaring a variable right here and then using it right down below, and we don't really need to define that as a variable, and we can just put it here directly. But just for reading purposes and making it easier for you guys to look at, I'll leave that up there, no problem. Again, I can do the same technique for this one. Instead of having a bunch of if, else, if type of conditions, we can have this scenario here. And I want to reverse the keys and values here. Okay. So if you give me 0, you get back rock. If you give me 1, you get back paper. If you give me 2, you get back scissors. So that's essentially what we're doing here. And this function expects a number between 0 and 2, including 0 and 2. So this is pretty straightforward. It'll evaluate to either rock, paper, or scissors. Okay. This is why the function is called number to choice. It takes a number and converts it to a choice. All right, how do we randomly generate the computer choice? Well, that's, thanks to the random module that we imported here, we can use that to actually do this problem. We can say return random.choice, and random.choice takes in some input like this, like a list. So we can go rock, paper, and scissors. Now make sure your spelling is correct everywhere, because if you are not consistent with your spelling of scissors or rock or paper, your program might not work because it's expecting specifically those things, right? If I open up a terminal and I go and open up Python here and we check what that does, right? So let's do import random. And let's do random.choice and pass it a list of things like A, B, and C. Let's see what it does, and let's keep running it. So hopefully you're getting the idea that it randomly picks something. It's not just picking one thing, it's randomly picking between those 3 choices. So just like that, you want to do rock, paper, scissors, because when the computer is playing, he's randomly picking between rock, paper, and scissors, right? So this is a simple one-line solution. Now this is where the meat of the project is. And this part is pretty tedious because you have to write a lot of if else type of conditions. I'm going to show you a cool way to bypass that, okay? So I have example code here for you, and this should be pretty self-explanatory. Okay, so you pass this function human choice and computer choice. If human choice was rock and computer choice was paper, well then paper beats rock and you increment computer score by 1. The reason why we're saying global variable is because we want to specify we're using these variables here outside of the functions, and those are the ones we want to increment. Okay, those are the ones we want to change. If you don't do the global variable thing and then you change that, you're only going to change the computer score within the function, but once you leave the function, it's going to be the same. So for example, if I don't use global and I do this computer score plus equals 1, inside of the function, computer score might be 1. Okay, computer score might be 1 inside of the function, but when you go outside of the function and you print computer score, it'll say 0. Okay, so by saying global, we're saying, hey, that's the exact variable we want to use, and if I change it, I know what I'm doing. I want to change it everywhere. Okay, generally you want to avoid using globals, but for now I want you guys to be, just use globals. It's fine. The reason why I say you want to avoid that is because then you can have, if you have really big pieces of code with thousands of lines or hundreds of lines, you don't want global to be changing between two functions, if you have 2-3 different functions, if they're changing it, if they all have access to the same variable, they might be changing it in a way you don't want. So you might want to give all of the functions its own separate variable so they don't have a collision with each other. Okay, that's kind of the reason. So okay, that's a little bit behind choice result, and
what it takes in as inputs and how we can use that. But instead of coming up with a lot of if-else statements, here's a nice little solution that we can do. So essentially we can say, hey, if human choice, it's a weird trick, so sometimes I have to see if I can remember it as well. If you take the difference between human choice and the computer choice, and this is where the choice to number functions come in handy, because what we want to do is we want to take their numerical difference. You can't take a difference of strings, right? Like you can't do hello or rock here minus paper. You can't do that. So we want to make sure that these are numbers. How can we do that? We can say human number is equal to, let's call our function choice to number function. And since we already have the human choice, we can just pass it in that human choice and it'll return it as a number. So for example, if the human was rock, it'll get thrown into the choice to number function and that'll convert it correctly. And so this whole thing will evaluate to 0. Okay, so let's leave it like that. And we're gonna say computer number is equal to choice to number function and give it the computer choice. Okay, pretty simple. So we have the computer number, human number. Now we can take the difference. We can say human number minus computer number and if you take their difference and you modulo it by 3 and you get back 1, if you mod something by 3, you'll create a world where the only possible numbers are 0, 1, and 2. Okay, so for example, just to play around, sometimes playing around with it is a very good idea. Instead of doing all this theoretical knowledge, sometimes just play around with it. So like let's do 0 mod 3. Let's do 1 mod 3. Let's do 2 mod 3. Let's do 3 mod 3. Let's do 4 mod 3. Let's do 101 mod 3. Let's do some random number mod 3. And as you can see here, the only numbers that we're getting are 0, 1, and 2. You're creating a world of only 0, 1, and 2 numbers. So modulo lets you wrap things around, which is kind of nice, because we have rock, paper, and scissors. So we want to be able to go 0, 1, 2, 0 being rock, 1 being paper, 2 being scissors. And then the next one, the next number we want, instead of it being 3, which is not in our list, we want it to be 0 again. So we want it to essentially be like 0, 1, 2, 0, 1, 2, 0, 1, and 2. So 0 corresponds to rock, 1 corresponds to paper, this corresponds to scissors. Then this corresponds to rock, this to paper, this to scissors. Okay, this ensures that we never get a number that doesn't map to one of our existing things. Okay, like essentially what we don't want is this, because when it tries to look up 3 and 4 and 5 and 6, it won't get anything in our database or our dictionary that we have. So we're gonna say take the difference and mod it by 3. We know for sure that we're gonna get some number like 0, 1, or 2. If the number is 1, then computer wins. So basically what we say is computer score plus equals 1, or you can write it explicitly like computer underscore plus 1. We can say else human score is equal to human score plus 1, and we need to have one last condition. That would be what if they have the same choice. So if human number is the same as the computer number, then maybe we just want to print tie and do nothing else. Okay, like we don't want to increment any scores, we don't want to do anything, we just want to print tie, that's it. Okay, So yeah. All right. So this trick is a little weird, but essentially what it allows you to do is it takes care of all the possible scenarios. Instead of you having to write 9 different conditions or 6 different conditions, I think it would be 6 because you have 3, so 3 factorial. So instead of writing 6 different possible situations like rock versus paper, paper versus scissors, scissors versus rock, and writing all those if conditions, this allows you to write, like, capture it all in just these 3 lines. The logic, I put some notes here at the bottom so you can kind of understand how the logic of it works, okay? So let's say that 0 is rock, 1 is paper, and 2 is scissors. If you do rock minus scissors, mod 3, and check if it's equal to 1, essentially what happens is rock is 0, scissors is 2. 0 minus 2 evaluates to -2. -2 mod 3 gives you back a 1, as you can see here on this left hand side. Okay, so if I did -2 mod 3, you get back a 1. Okay, and 1 equals 1, so it goes rock wins. And it's true, rock would win even if you just visually look at it. Then we have the scenario with paper versus scissors. So paper is 1, and or actually it should say scissors here, I'm sorry. So paper versus scissors. So you have 1 minus 2, right? Paper is 1, scissors is 2, as you can see here. 1 minus 2 mod 3. Let's check if it gives us 1. 2 equal signs mean check if it's equal to 1. Then 1 minus 2, that gives us a -1, right? This gives us a -1. We mod it by 3, and -1 mod 3 gives us 2. We check if 2 equals 1. Since 2 does not equal 1, we give the win to the other side. So we give the win to the right-hand side. In this case, the right-hand side is computer, and the left-hand side is the human choice. Okay? So if the mod is ever equal to 1, then essentially what we're saying is that the human wins. And if the mod is not equal to 1, then we can say that the computer wins. Okay? Let me just check this against my solution code that I have. And yeah, that's kind of what it says. It goes, hey, if it's equal to 1, then computer wins, otherwise the human wins. Okay? So let's go back up here. This looks good. This looks good. And yeah, I think most of the code here looks good. Now, let's first test our code. Let's run this guy here. What's the error? Oh, we would pass in number, right? Because that's our argument now. Okay, so we passed all the test cases. Let's see if the game runs. Okay, you picked paper, the computer picked rock, so you win. Perfect. We both picked rock, so it was a tie. Let's do scissors. Yep, scissors beats paper. Okay, so there you guys go. The game is now working. I have shared the link with you guys, so you can actually go play it there. And if you wanna try again now to try to solve it, after looking at my solution, see if you can now try to solve it without looking at the solution. So I'll have the project, the problem there for you guys, so you guys can actually try the problem on your own. And I'll also have the solution there for you guys. And you guys can just hit save at the top left here, and then it'll give you a link, and you guys can just share that link with anybody that you want. And so then you can share this with your friends, family, whoever. Okay, guys? Hopefully that explains it. You guys had fun doing rock, papers, and scissors. And the next project, what I would like to do is build a text messaging app. So we'll have an app which can send out texts to other phones. All right? All right, guys, take care. Have a good one. I'll see you guys in the next video.
Back. So here's another cool pattern using the list that I want to share with you. So let's say we have a list of numbers, okay, and what we want to get back effectively is something that squares it. So the result should look like 1 squared, so that's just 1. 2 squared, that's 4. This 3 over here squared, that's just 9. That 4 over there squared, that's 16. 5 squared is 25. 6 squared is 36, and I think you get the idea. So we would want to call that list the squared list, or we can say squared numbers, right? Since this list is called numbers. So how do we do that? How do we turn this list into just all of these numbers squared? Let's figure it out. One way you would do it is you could type it out manually, but that's going to be a lot of work, right? That would mean that you would do squared numbers dot append. Append is a method that allows you to add to the list. So here we have an empty list, and since we want to add something to it, let's just show you what I mean. Okay, let's say we want to add a banana in there. Okay, and let's print out squared numbers. When I run it, you can see that I've now added a banana. Let's throw something else in there. Okay, let's throw apple. Okay, let's run through it, and you can see now banana and apple are added. Okay, so append just simply adds something to the end of the list, hence append. Okay, so going back here, what we want to do is we want to essentially append each of those numbers squared. So how can we do that? Well, we leverage off what we learned in our last video. So we do for number in numbers. This is now going to give us number is going to be 1 the first time, 2 the next time, 3 the third time, and so on and so forth. And what do we want to do? We want to do squared numbers dot append number, and so we're appending now the number. So we're going to basically every time we go through the loop, we add 1 the first time, then we add 2 from this list, and we add 3. But we want to actually add the squares of those numbers. So we want to do this, and now let's check out what squared numbers looks like. And that's it. Okay, simple as that. Very good pattern to remember, and it works. Okay, so play around with it, see if you can do something like cubing it, or change up this list and see if you can do something like dividing it in 2 every single time and then appending that, so you can call it like half numbers. Yeah, practice it out. Run this code. I'm going to add the link of this in the below the video or above the video, so you guys can actually go directly here and play around with this. All right, guys, thanks for watching. I'll see you in the next video. Hey guys, what's up? This is Kazi from cleverprogrammer.com. Let's jump on and talk about tuples. Okay, this is something we did not discuss in our data types yet, and we need to cover this concept. So remember when we had lists, and you can add things to lists and delete things from lists, and lists are super nice. So, you know, list would be something like groceries, and if you said, okay, let me turn on this one thing so it does not keep bothering you guys. Okay. All right, there we go. Now remember, list was like groceries, and you might have a banana and apple. Groceries, that's funny. Apricot. Okay. Well, with tuples, you can use them a very similar way. You could have, let's make it something that you can't change, for example, or, you know, social security numbers. I mean, you could use whatever you want, but I just wanted to use this one. And it could be some number here, it could be another number right there, and then another number right here. Okay, so this here is actually called a tuple. Why is it called that? Nobody knows, but it's wrapped in parentheses. And the main difference between a list and a tuple is that you can add things to a list and delete things from a list, but to a tuple, you can't change it. You can't add things to a tuple or take things out from a tuple. So that's really the key difference. I'm going to go down here and show you, okay, groceries. We can do .append cheese. Okay, and if I print out groceries here, okay, and you'll see the results at the, oh, oops, this ran on a different file. You can see the results right there. It says apricot, banana, apple, and cheese, because I just added cheese to it and it shows that. You don't have a method like .append for tuples, so you can't do that for them. Okay, this was just a very basic example of this. Why would you need to use a tuple? Well, if you were working with data that you really never want changed, like maybe you were storing people's passwords, you never want to you want to store them like this, because maybe that's something you might now want to change, right? Or at least you might want to make it really difficult for people to change, even people who are programming those websites for you, or if you're programming a website like that yourself. Just really quickly, let me show you where you can actually find this code. So I'm going to actually push this code up for you guys, okay? Let's see here. Add, learn, whoops, Python. Okay. So you guys can actually go to github.com, okay, and look up my username, so maybe Clever Programmer. And one thing you can do is go to users and follow me, okay. But if you can't follow me, just look for Clever Programmer _stuff, this repository. Go to this repository right here, and you will see Learn Python. Okay, there's the link. If you want to go directly, github.com/cleverprogrammer/cleverprogrammer _stuff. And in there you'll see something called Learn Python. Go in there, click tuples, and you can actually see the code right there. And that's where I will, let me make it a little bit bigger so you guys can see it better. This is where I will try to add the code for you guys from here on out, and you guys can just go ahead and check everything right on there. Okay, hopefully that clarifies everything. All right, that's it. In the next video, perhaps we're going to cover a little bit more about mutable versus immutable data types. So I'll see you guys there. Hi. So just a little bit about mutable data types versus immutable data types. Essentially, to mutate or mutability or mutable essentially means something that can change. They will use this terminology in computer programming world to confuse the hell out of you, but essentially it's just telling you that something can change. And immutable just means something that cannot change, okay? So, for example, I don't know, some things might be immutable. Like I might consider maybe my glasses immutable. They're really hard to change, and I mean, it's really hard to change something about it, and that's just what it is, right? And maybe my keys might be a little bit more mutable. Like I can add things to my keychain, and I can take things away from my keychain, right? So that might be an example of something that's immutable versus something that might be potentially mutable. You know, your wallet, you can change things, you can add things to it, you can take things out, but maybe from a cup, it's a little bit harder. I might almost consider it an immutable thing. Maybe you could put something in it. But these examples are just to give you some kind of intuition as to how these things work. But in the real world, you know, you're doing data analysis on a lot of sensitive information. You want to store that as a tuple where it's harder to change it. Or if pairs of things go together, like for example, your name and your email address, that's something that goes together as a pair, then maybe you could put that, you can create a list that contains tuples inside of it. So the first element of that list could be a tuple containing my name and my email address, and then the second element in that list could be your name and your email address, and so on and so forth. And the reason why they're a tuple is because you can't take things out from it really easily, or you can't add things to it really easily. So generally stick with a list until you can figure out when to use both of them, and then start using tuples. But for now, play around with tuple a little bit, figure it out, get a sense of it. Alright guys, that's it for this video, and I'll see you in the next video.